the people they are actually the people who develop the whole solution, whole platform. So they know the insights and out of the platform. Yeah. So it will be an interesting 2 days, and hopefully, because you guys are also actually the first batch to attend a professional certification. Yeah. So there will be exams that you go through to get a professional certificate. Yeah. So that will be paid by Dr. Gopi later. Yeah. So thanks again to Dr. Azrami and the team here for being our participants for the next 2 days. Thank you.
All right, thank you to our favorite CEO, Dr. Mazlan Abbas, for your opening remarks. And next, I would like to invite Dr. Azrami Abdullah Al-Hadi, the Dean of Faculty of Electronic Engineering Technology, for your opening remarks too, Doctor. Over to you.
Okay, thank you very much, Madam Zura, Dr. Mazlan Abbas, Dr. Gopi, and also probably there's another one from Favoriot.
Nazrin.
Yeah, Mr. Nazrin, and fellow colleagues from UNIMAP. Thank you very much once again. I think everybody knows already, especially for the lecturers, knows about the IR 4.0 and also IoT, one of the pillars in IR 4.0. And then once I received the invitation or offer from Favoriot about this training, I was very excited because I believe that it's not only for the faculty of electronic, but also for other faculty members. I think it's very exciting if we can see mechanical lecturers using this IoT platform to know the vibration of the machine and temperature and things like that. So it's not only focused for electronics as what Dr. Mazlan has mentioned just now, but I think other lecturers also very excited to know how to use this IoT in their curriculum structure. And then I also believe that all the participants ready to attend for the examination, because professional certification is very important, Dr. Mazlan and team, for the faculty and for the program accreditation, because the accreditation body would like to see at least 30% of the staff, if they are not having any industrial experience, but at least they have this professional certification. So I think this is probably one of the way forward for the Favoriot to offer the universities. And then when they can see this kind of opportunity, probably they will try to grab this, and then of course try to see what kind of Favoriot we will offer in terms of price and things like that. So that's the pricing is another matter, but the faculty obviously would like to support and then to be part of this, as what Dr. Mazlan always mentioned about this generation IoT. So we want to be part of the team and very keen to look forward for that. So I think that's all from me. I hope that all the participants enjoy the session. We'll have this practical. I believe you all have received all these IoT kits, and then enjoy the session. Thank you very much, Dr. Mazlan, and back to you, Madam Zura.
All right, thank you so much, Dr. Azrami. So, so for this 2 days training, it will be conducted by our CTO, Dr. Gopinath Rao, and also assisted by Encik Muhammad Nazrin, our IoT developer. All right, so enjoy your training today. But before we start, perhaps can we open up our videos to just get a quick photo session? So Dr. Gopi will help me to take the pictures, yeah?
Yeah.
Okay. Dr. Wijaya. Dr. Muzaidi. And Dr. Nur Fatihah. Tak ada.
Shall we take?
All right.
Okay. So 1, 2, 3. Hold on, I'll take another one.
Okay.
1, 2, 3. Right.
Okay. All right, done.
Yes.
Okay. Okay, thank you so much, everyone. So without further ado, I will just pass over to Dr. Gopi to start the training. Thank you.
Thanks, Zura.
Welcome.
So good morning, everyone. Hope all of you are in good health. So let me just start the session for today. Is this the one? Yeah. Okay. So all working from home or already in office already? Start office.
Office.
Oh, already in office. Huh? Okay.
Yeah.
I mean, the new students already in, right?
Next week.
Okay.
For the first week, yeah.
Oh, after what? After more than a year, right?
Yeah.
I'm sure students are also excited. In fact, one of the experience of studying university is the experience in the campus itself.
Yeah.
It's a bit like they left out the big thing.
Yeah.
That's what I feel. Yeah.
Online class quite boring, actually.
Why is that so?
Because online, right, you cannot see the face.
Yeah, exactly.
So it's not
exactly.
interactive, not so interactive like the face-to-face.
Yeah. And I wonder how, like mechanical and other things, more towards also hands-on and so on, by practical sessions. Wonder how they did the hands-on.
Some they come back.
Oh, they do. Okay. Limited numbers.
Yeah.
All right. Good. So again, good morning, everyone. So I know that we have 12 participants here from various faculties. Thank you for attending this session. So we'll make sure that it will be interesting for you. And I've seen that some of you have sent your pre-training queries. I think most of you have no experiences in Arduino and platform. Maybe one or two have experience or did some projects in IoT. Good. But this, as I mentioned, this is a fundamentals training. So we will try to go slow as possible so that we can actually pick it up. We can actually apply what we have learned here in either developing a solution or for your teaching purpose. By the way, may I know if you all have any IoT type of program or course? No?
Yes.
Oh, you do have. All right. Is a degree program or just a one subject?
You mean a program? Sorry, not program, the subject.
One subject.
Yeah.
Okay. All right. It's already started. Yes.
Sorry, Arif from materials engineering.
Yes.
So basically, we are coming from multiple field and backgrounds, right?
Yeah.
So like me, I'm coming from zero knowledge on the IoT, but I'm joining a few webinars on IoT, but very basic on understanding zero and IoT. But in terms of devices and the script is quite new to me. So hopefully I can catch up with you all. Hope I can learn a new thing.
Sure. No worries. Sure. Okay, so let me start. You can see my screen, right? Okay, good.
Yeah.
So this is a 2-day program, as you all know. Just about myself and Nazrin. So let me just explain about myself first. So you can call me Gopi throughout the training session. I'm currently the CTO for Favoriot and also the chairman for Malaysian Technical Standard Forum for IoT and Smart Sustainable City Working Group. Also the CTD certified trainer. So my background, I've been working with Dr. Mazlan more than 10 years now. In various organizations as well. We started work on IoT back in 2009, 2010 when we were in MIMOS. So that is more towards research in wireless technology. So I look after wireless sensor. So that is how we started the journey. In fact, from then onwards, we actually part of the team to build the Malaysian first IoT framework, which was launched, I think, about 5-6 years ago, if not mistaken. So that was the first attempt. I mean, we worked at the national level for IoT. It's more towards a documentation level. But after that, we moved on, wanted to create more IoT generation, as Dr. Mazlan, termed it. We created our own a new startup company under Redtone, looking into specifically on IoT platform, and then we moved on, created Favoriot as is now. In terms of standardization, so I'm also leading the standard groups under the Technical Standard Forum, which is directly under MCMC. What we do is that we create new standard documents specifically for IoT, which we align to ITUT and also Asia Pacific standard, which is called ASTA. ITUT specifically on SG20. In fact, this week and next week, there is an ITUT meeting for SG20. So there are a few documents that we have created under the MTSFP. One is that IoT Smart Sustainable City framework is a very fundamental standard document. The one is completed IoT high-level functional architecture. There's one. One it is about to complete is IoT communication and connectivity framework. The next, what we are planning to do is that baseline security for IoT consumer devices. Now, this is very important. I will let you know, I will explain a bit on security aspect, why is it important. And also smart sustainable city interoperability framework. Now, the members for the standard working group consist of universities. I'm not so sure if UNIMAP is there, but there are other universities involved. For universities, I think it is free for them to be a member. Yeah, I think UNIMAP is part of member. One of the faculty, if not mistaken, they got a grant 2 years ago from MTSAB. Okay, we consist of university, experts from industries who want to build a new standards for Malaysian IoT and so on. All right. Of course, I've been a trainer for some time. Started with IPv6 long time back, and then moved on to wireless sensor, and now with IoT. Nazrin has been with us for almost more than, I think, almost 4 years now, I think. He's our strong guy at the back end. So he's the main person who actually built the platform itself, and also adding new features as we go along. So there will be new features that we add on to the platform, which I will explain again later during the training. Right. Just a bit on Favoriot. We established in 2017. It's going to be 5 years in February. So we are located in Puchong. Of course, what our vision is to IoTize every business. So when we say every business, it means that cut across every sectors, from agriculture, from home automation, from smart city, and so on, because IoT cut across in various segments, right? So that's the reason why, besides us being in the platform business, platform as a service business, we also try to encourage, get as many students, as many developers to play a role in this IoT business. We have 3 main products. Favoriot IoT platform. So this is our core that easily aggregates IoT devices, data, and derive insight from it. Second is the Discover. I'll explain maybe tomorrow about Discover. It is about connecting family members, friends, colleagues, and so on, where they can share their real-time location if they want to enable that part. Also activities, moments, plans, things to do, and many more. So those who are familiar there are similar apps like this, but this is our homegrown app. It is freely available, so you can download it for free, both iOS and Android. The third one is the FavorSense. FavorSense more towards a crowd sensing management platform that builds better, smarter communities. So it's not only meant for local councils where they can actually provide to their people, to their citizens, to make report about the issues that they face in their, for example, the housing area and so on. It also meant for, facility management. It's for construction sites, for anyone who want to get the issues that they face. For example, a drainage issue, pipe breakdown, and so on. So many things. So instead of us complaining in Facebook, Twitter, and so on, we can actually use the particular app to escalate it smoothly from the mobile app to the one who's going to resolve the issue. So it's a very systematic approach for this, right? So that's about our Favoriot and us. The next is that Favoriot IoT training path. So let me just explain a bit about this training path. The training path, we build it such that it applies from novice to specialist, and it is followed through 3 levels. The first level that what will be doing today and tomorrow is the fundamentals. So it consists of few parts. The first one is more towards theory, but I will also get a feedback, your opinion, your input during the introduction to IoT. Basic of IoT design thinking. Let's see how it goes about timing. If we have time, then we will do this today. Otherwise, we will do it end of tomorrow. Next is that configuring devices to connect the platform. I assume each one of you already received your Hibiscus Sense, the device that we will be using to connect to the platform so we will be using REST, CoAP, MQTT, and RPC. It is a mouthful, it's quite a lot actually, but we will go slow. This is just as introductory. So we'll explain the fundamental things of how to use this various communication protocol to connect to the platform and send the data. Simple data simulations tools. Sometimes it is important for us to understand, to use these data simulations tools. We'll be using Postman and also Hive MQTT client for MQTT. And also, of course, the Favoriot IoT platform itself. So we will explore step by step all the functionalities that's available, what you can make use of, create widgets, create graphs, and so on and so forth. So this is a fundamental. And all the exams that you're going to attempt based on whatever that we will, teach in these 2 days, including hands-on as well, but it's not too much actually, don't worry. So this is 2 days. Now, next is the intermediate. So intermediate is more towards, it is a 3 days. We will go end-to-end design thinking, starting from identifying the problem that we receive. Because if you look into design thinking, the important thing is that how do you, frame our structure so that we can solve the issues. So first identifying the problem, and then specifically look into identifying the devices, the connectivity, the platform, and the dashboard or the application part of it. And then next, setting up an IoT gateway. So we will use one of the device to set up as an IoT gateway. See, here is individual device, but here we will work on connecting this individual device to the gateway. May be using Node-RED. For now, it's Node-RED on IoT gateway. We will also build a simple mobile app, and also towards the end, understanding the security and privacy risk on IoT project. On the third level, IoT specialist is 4 days. It's more towards data analytics. So we will look into big data analytics, connecting IoT platform to third-party analytics. For your information, Favoriot platform, for now, we're still actually adding on few features, but for now, we do not have specific analytics tools, right? So for that matter, so we need to use a third-party tool. And in fact, if you talk about analytics, it's a very domain-specific. Agriculture requires specific domain. And then if you talk about medical related things, then it's a specific domain. So all require different sets of models of analytics. So that's for that reason, it is best to use a third-party analytics tools. We will look into processing IoT data analysis, and then end-to-end IoT security, and then look about a bit on IoT standards and more towards the end projects and case studies. So we will discuss about the project and see how we can actually build on paper an end-to-end IoT solutions using the design thinking that we have actually learned in the previous. So this is the standard training part for IoT. We have also IoT security professional part. It's not started yet, but this is the plan. So security is specifically focusing on the security part. The fundamental is a 3 days program. Introduction to IoT, configuring devices, again, this is a fundamental understanding, but more towards understanding end-to-end security and providing IoT security guidelines, right? And then the 4-day, looking into specifically on IoT security. So IoT and risk, dissecting the end-to-end IoT security, OWASP, top security vulnerabilities, guidelines and recommendations, as a compliance framework, implementation security best practices. In fact, there are a standard questionnaire that we can attempt to when we want to deploy an IoT solutions. And how do we manage software and firmware hacking IoT devices? Right, so these are the security part. And of course, the last one is the IoT Masterclass for business leaders. This is a 1.5-day program. Very high level. There's no hands-on in terms of building using the business canvas model. So what we do is that map IoT into business canvas model so that they will know there is a profit out of it and so on and so forth. So this is what it is for the training part that we have. Now, you can always stop me along the way if you have any questions, right? So for this 2 days program, so this is the day 1 and day 2. Let me just go through what we will be learning together. I mentioned onboarding and so on, training expectation. The first half until 10:30, so we'll have a short break, maybe about 15-20 minutes. Let's see how it goes. It's more towards introduction, Internet of Things. I know that most of you have experience, some knowledge in IoT. So this would be some kind of a refresher for you. For those who are new, this will be a good, knowledge sharing, I would say, right? So we will look into this introduction to Internet of Things, ecosystem, X component until before lunch. The dissecting IoT solution design thinking. Again, let me see how is the time. If time permits, we will do this today. Otherwise, we will do it this particular thing tomorrow. Slightly before the break or maybe after break, so we will do hands-on on preparing the platform to receive data from the device. So we will go step by step on favorite IoT platform. What are the things that you need to look for, and so on, right? By the way, have everyone, all of you have registered a favorite platform, right? Favorite IoT platform?
Yes.
Yeah.
All right.
Yep.
Okay, great. So we will be using that account. And then we will have a short break at 3:30 for 15 minutes and followed by hands-on on preparing, Arduino IDE, the environment. And we will be using Arduino IDE to configure the Hibiscus sense that you have. So this is more a coding, but it's not very detailed. So everyone can pick up this particular coding. Right, that is for today. For tomorrow, so we'll recap. Again, we will continue from here. We will connect sensors to favorite IoT platform. So we understand the Arduino IDE, set up the basic environment, understand the Hibiscus sense and so on. But here we will connect or read data from Hibiscus sense. There are inbuilt sensors, so we don't have to worry about fixing another component, another sensor. It's all there. So we'll try to read the sensor data, send it to the platform using REST and CoAP. So this is two different communication protocols. So we will try to understand what's the difference between these two, and so on, right? And then a short break, and then followed by data management on platform. So because we have continuously been sending data to the platform, data now resides in the platform. Next thing is that what can we do with the data, right? So we will create a simple dashboard. We will create rules. We will try to export data, basic analysis, and so on. And then tomorrow afternoon, after the lunch break, we will use MQTT and RPC to send data to do a basic actuation, right? So we will do until the end of tomorrow. See, all the while until here is basically sending data from the sensor device to the platform. Towards the end, what we would do is that we try to control the device by sending certain commands. So it's basically a two-way kind of a communication. And for that, we will be using MQTT and RPC. Right, so that's all about towards the end, recap on learning. And of course, the learning outcome, so what is expected? First thing is that understand the components in an IoT ecosystem. It is very important for us to understand each component for us to build a better end-to-end solution, right? Second is that to connect IoT device and send data to favorite platform. So we'll be using Hibiscus Sense and also the account that you have created in Favorite. Third is that to manage favorite platform for IoT project development. So as I mentioned earlier, so what to do with the data that you have collected. So we try to set the rules, download the data if you want to create graphs and so on. And the last one is understand and apply the use of different communication protocols, REST, CoAP, MQTT, and RPC. Now for training requirement, Hibiscus Sense, I've mentioned earlier, Hibiscus Sense. Arduino IDE, for those who have not downloaded it, you can just type Arduino IDE download. So you should be able to see, I think 1.8.16 is the latest. So you can download that. It's a Windows 7. So you can get the Windows, this one, the top one. Don't get the others, the Windows app. Just get the first one there. So that's Arduino IDE. Postman, so we'll be using Postman tomorrow. So if those who have not downloaded, you have two choices. Either you can download the Postman app, or you can register online. So you can use a web base. Okay, the same thing. Of course, favorite IoT account. Right. The last one, of course, be casual. I don't want it to be too serious. I want a two-way communication so that we will also improve. I know IoT is such a huge, very broad, right? Sometimes you may know better. So maybe you can share some of your experiences if you have, and then let's move on. All right, good. Any questions so far? If no, let's move on. Okay. I've shared the folder for the training. Let me just share. Right. Now, in that folder, IoT Fundamentals Training, UNIMAP, this one. So there are 3 subfolders, codes and libraries. So we will be exploring these codes in the afternoon today. We will look into some of the codes and then the rest tomorrow. And there are some libraries here. So we will guide you on what to do with these libraries as we set up the Arduino IDE. Right, that is for the code. For handout, so I've structured it such that it's a 1, 2, 3, 4, 5, 6, and so on. there is Favoriot IoT platform manual. So we will also use this. So it's practically follows this flow, right? So you can always refer whenever you can download it and use it whenever you want to. And then driver, if it's need to, again, it's only if it is need to, right? So this sometimes what happens is that when you plug in your Hibiscus Sense, your laptop would not detect because of the USB port and so on. So for that, you need to install this Universal Windows driver, right? Most of laptops should not be an issue, but in some cases we see some get issue on this, right? So this is on the platform. All right. Now, during the first part, I mean, today, I will also be using two tools. One is Mentimeter. Mentimeter is just for the beginning part of it. And then Nearpod, right? So Nearpod is to get your feedback on some of the questions that I will post later. Now, for now, let's see. Let's start with the Mentimeter. Now, I know it's 12 of you all here, so I just want to get to know about yours. You can just type in here, click the link, and maybe want to attempt this. Right. So you can see. Right. So how are you feeling right now? I know some of you are distressed for the next week's classes, maybe. I mean, it's just an interactive part, right? Excited, all right, confusing. It's good to be confused because at least we will know that, you know, we can enlighten you something. Nervous? No, nothing to be nervous of, right? All right, optimistic, great. We're excited to learn more. Good. Excited to learn. Right, confusing, interesting, workshop. Anyone else? You can actually, I think, type in more than one if you want to. All right. Trying to understand. Optimistic. Enthusiastic, right? Curious, great. Okay, so good. Scared. Scared, nothing to be scared of. Everyone actually learning and relearning, so nothing to scared of. It's a continuous learning, so no one is expert here. Everyone is learning. All right, good. So let's move on. How to move this one? Okay. Let's move on to the next one. So what would your pet, if you have a pet, a real imaginary, say, if I thought you're all still working from home, so I prepared that such that, say you are getting on with work from home. So your pet looking at you, working every day at home, what would that pet say to you? Or if you have an imaginary pet, so you can imagine, you know, what this flow always at home when you don't want to go out, you know, get out from the house. I mean, something like that, right? You're boring, man. Yeah, exactly. Sometimes I feel, you know, being at home. In fact, we are still at home. We are still working from home. We'll go back to office next week. So what now? Get a life. Yeah, true. True. I think most of us are waiting to go out. Now the interstates are open. So this weekend, I think it will be heavy traffic everywhere. Stop eating. So you're eating more at home, right? You again. Same faces again. You are boring, man. Right. Stay away from laptop. Well, you know, that's our job. That is the most difficult part, to stay away from laptop. If we are stay away from laptop, then there's something wrong with us, I guess. Get alive. Seems talking to myself. So what now? Okay, anyone else? Okay, all right, great. Okay, so let's move on. Let's move on. Okay, so one more. Seems talking. Leave me alone. So disturbing your pet. Right. So this could be your imaginary self talking to you as well. So you should know better about yourself, right? So, okay. All right. So this is about. Now, before I start, I want to know what is your expectation in this training. So for that, so I'll be using this nearpods, and I'll just share in the link here. Right, so that is nearpod. If you have an app, so you can type in this code. If you have the nearpod app. This is, have you used nearpod before? Anyone used nearpod? No?
No. Never used.
Okay. This is a online teaching tool actually. So there you can set up questions, you know, brainstorming session, get feedback, and so on. It's very interesting. Very interesting. So we have, say, you just need to type in your name only. That's it. Oh, sorry. So let's wait. Student. Okay, so we have two. We'll wait for everyone to join first, and then I will start the first question. So I see 3, 5. So when you type your answers, I will share the answers to all, but your name would not appear there. Okay, so it will be anonymous. So people won't know, so don't worry. I know, but I know. Okay, so we have 1, 2, 3, 4, 5, 6. Another 6.
Did I miss something? Do you share something?
In the chat, if you click the link that I've shared, the nearpod.
Okay.
Okay, we have 7, 8, 10, another 2 more. Okay, so we have 10. Okay, 12. All right, great. So all joined. So now the first question is about what do you want to learn, right, about IoT? Specifically, these 2 days. I know 2 days is a very short, but what is your expectation, right? So you can type in, I think 250 characters, and you can type as many, you can post as many as you want, right? So once I receive your post, I will share it, and you should be able to see in the board. As I said, Don't worry, so your name would not appear. All right. Oops. Do you see your name? No, right? Right. Okay.
Yeah.
No. Send. Okay. Okay, any other? Okay. Okay, so let's look into this. Okay, so explore new knowledge, send sensor data to web-based display, right? So we'll be doing this. I want to understand detail about IT directly from the expert. I want to try IoT, great. Want to learn about devices and software. Yes, we will be learning, a bit of devices and software. Theory and practical, right? Able to control mechanisms, right, on developing some systems related to IoT, learn about coding in IoT and how it is implemented, understand each protocol, right, explore on how the IoT can be related to materials, right, okay, how it can facilitate humans' life, right. I wish to start a simple project using IoT, okay, how to start learning IoT. Is it IPT or IoT? IoT, I think. And one more. The general concept of how IoT works and how it communicates with multi-device in real time, what kind of server involved, and its security. Great. So we will be learning most of it. And let's see, some maybe not to your expectations, some very fundamental, say it's a fundamental, but we will try to explain as much as possible so that you understand the concept or the whatever information, knowledge that is required for you to start an end-to-end IoT solution. Great. So let's start with the first part. Introduction to IoT. Okay. Okay, so this is more towards theory. I hope you can bear with me. Now, any one of you know who coined the term IoT? Anyone?
Sure. No.
No? Okay. All right. Now, IoT term was actually coined by Kevin Ashton, right? Back in 1999. So he was MIT at that time. In fact, IoT was not new at that time. What I mean by not new is that it is actually started with M2M, machine-to-machine communication. So if you notice those, this is 1999. So in 1999, yeah, I just graduated that time, 1999. So you'll understand, the processing power is not there. No laptop. Don't even imagine to have a laptop that time, right? So computers are so expensive. I still remember my computer that time, I think, if I'm not mistaken, is it 16 GB of hard disk or something like that? So it's very small, right? And so expensive, processing is so slow and so on. But even then, M2M was there. So M2M or machine to machine was used, for example, for tele machines, right? Machines, ATM machines. So unlike now, those days ATM machines have a connectivity. So whenever you, when you withdraw money and so on, it sends using M2M. At the same time, it's also be used for something to do with if you want to purchase something, you know, like the Coca-Cola cans and all their box and so on. So it also has a kind of a end-to-end, right? So it's a machine-to-machine communication. So that is the precursor, the starting of IoT, right? So from there, Kevin Ashton feels, okay, there's so much that we can do, that we can evolve from IoT, I mean, from M2M, by connecting, building application and so on. So that he coined the name Internet of Things. Very fundamental. Not many people started immediately, of course, but it evolved over the years. Simply said, Internet of Things is internet connected devices that collect and send sensed data. So sensed data here means the data that is from a particular sensor, right? A particular sensor that will be used to improve existing service or solve a problem. If you have problems with the existing solutions that you have, you can apply some sensors, collect the data, send it over to provide a better solution. So that is the general concept. So I will go in another definitions after this. Now,
yeah.
Yes.
Is it must involve the internet? Or
Yes.
Intranet, okay?
Intranet or internet, both possible.
So we consider both also as an IoT.
Yes. Right. So this is the forecast from Statista. Now remember, different organizations have different forecasts. Now you may notice if you read some documents, right, from Cisco, from Ericsson and so on, they have different numbers based on their studies that they have done. But from Statista 2021, this is quite recent. So they said back in 2015, there were 15 billion IoT devices, and it will go up to 70 billion in 2025. That's a huge number. Again, don't take it as it is. So as I said, the numbers changes according to different organizations. But one thing to know is that it is increasing exponentially, right? It's increasing exponentially over the years. Why? I will come to that later. Okay, why is it increasing? Now, let's look at the definition of a proper definition or standard definition of IoT. There are two parts. I will go on the left hand first, this one, and then I will move to here. Now, this is taken from European Union Horizon 2020 project, one of their IoT project. So they have defined, this is quite some time back, but I like the simplified definition. What this diagram says is that an IoT is actually a thing that can be at any time with any content, right? Can be handled by anyone, that provides any services to any businesses using any path, right? Using any path or any network, that the sensors can be deployed anywhere, right? It could be in the deep sea, it could be on the mountain, it could be in the forest, it could be in the building, or any device, right? So this is what summarizes. In fact, in that particular document, I forgot to extract it. It gives in one paragraph explaining all these components. So very interesting. Yeah.
Does it include the satellite?
Yes. Satellite will be the communication part of it.
Oh, okay.
Yes. Satellite will be the any part, any network. I will explain that later on the satellite and other communication connectivity part of it. Interesting. So say any businesses, right? Any services. As I said, IoT cut across various sectors, right? Be it for monitoring wildlife, for example, or monitoring your own self, for that matter, right? As I said, it could be any place. You can deploy it not only in urban area, but in rural, in forest, on the mountain, and so on. So there are solutions that have been deployed to monitor the activity of volcano, right? So they put sensors to measure the vibration, the heat, and so on and so forth. So it could be any place. Now, IoT also provide a definition. What it says is IoT is a global infrastructure for the information society, enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication. A very mouthful, but as I said, simply you can imagine it's that there are devices that can sense data, send the data to be processed for specific cases, right? So some things here, for example, existing and evolving interoperable information communication technologies. Now these are, when you talk about interoperable, is a very, I would say, the system is not there yet. I'll explain later what this means and why is it important to have this interoperable ICT. In fact, they have stated three, actually two, I've added one more. Note one is that how to get the data is through the exploitation of identification from data capture, processing and communication capability. The IoT makes full use of things to offer services, all kinds of applications, while ensuring security and privacy requirements are fulfilled. You know, this is very important, security and privacy, but most solution provider, right? Most solution provider, in general, they may ignore this part because of the cost involved. Note two, in a broad perspective, IoT can be perceived as vision with technological and societal implication. Right? Again, people may overlook the societal implication. They use technology to improve the businesses, but not for human life. But it can be applied. Example of IoT in a broader perspective is IoT Industry 4.0 or in Malaysia Industry Forward and so on. Right. Now, when you type IoT, you may come across various terminologies being used. For example, Cisco said Internet of Everything. So you see, when Kevin Ashton proposed the name or coined the name Internet of Things, few years after that, Cisco came up with Internet of Everything, thinking that it can overshadow or their terminology will be used, but somehow it's not so. So Cisco said Internet of Everything. And then there's something called machine to machine, I've explained earlier. So it's a machine type of communication. GE, right, General Electric. So they said it's industrial internet. And then, as I mentioned earlier, industrial Internet of Things. Internet of Things for industry, for manufacturing, right? But this is actually a subset of IoT. Smart X, smart energy, smart grid, smart home, smart city. So this is also. And then Claro Partners. So they point Intranet of Things. Again, same. It is a proprietary type of solutions with a closed loop. Vehicle to X. Now this is interesting. So we have seen that, you know, more and more autonomous vehicle being deployed, right? So you see Tesla, we see Google also trying, you know, there are so many. Now, what is vehicle to X. So it could be vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to anything. All right. One example is that that is being deployed as a POC by Toyota in India. I'm not so sure which part or which city in India, but that particular area is a very bad traffic. It's a 2-lane highway kind of a thing, but the traffic is extremely bad. So what they wanted to do is that to have a vehicle to infrastructure communication. So this is for ambulance. When usually what happens is that they have noticed when there's an emergency, the ambulance will stuck in the traffic jam because nobody in front of the ambulance would know. Say for example, there are about traffic could be a kilometer, long. That's the bad. So what they did was they fitted the vehicle, the ambulance, so that it can send a communication to the billboards, which is in front of the ambulance. So the billboard will show that it's an emergency, please give way. Right. So this is kind of a vehicle to infrastructure type of communication. Of course, there are various scenarios, but this is what Toyota has actually done a POC in India. In fact, the person who did that came personally and then explained the system back here. This was about 4 years ago, right? So similarly, because autonomous vehicle requires a lot of sensors, it need to know sensors to detect the surrounding, sensors to detect the vehicle in front, sensors, various kinds of sensors. You have noticed a lot of sensors being used. In fact, with that sensors also, the accidents do happen with autonomous vehicles. These are talking about self-driving vehicles, right? So it's a very interesting vehicle to it. And then we have something called Web of Things, embedded internet. So this all actually is the same, right? It's a kind either subset or have a similar meaning as of Internet of Things. This is similar. There's no difference at all, right? It's just that the application would be different. For example, IoT is more towards a manufacturing industries. Like M2M, it's a machine to machine and so on and so forth. So it's the application of those technology will be different. But you can think all is the same. Next is why now, right? Why IoT is being or talked about or being applied most now. So as I said, even though it was coined back in 1999, sorry, the cost is so high. You cannot imagine to have a sensors. Sensors are so expensive. Processors are so expensive, right? So hardware is getting so much cheap right now, right? So cheap that that you can actually purchase it off the shelf, compared to those days. That's the first one. Second is the connectivity is pervasive. It's everywhere, right? You cannot say that you don't have connectivity. Of course, if you go to some rural area, you don't have connectivity. Sabah, Sarawak. Anyone from Sabah? Sorry. Sabah, Sarawak. Some rural area, we hear some places there's no connectivity, but majority of places connectivity is there. Even if we do not have connectivity, the technology is there for us to set up the connectivity, right? We're not talking about licensed connectivity, is unlicensed connectivity as well. For example, for IoT purposes, we can set up a LoRa network. It doesn't require a license for us to connect, right? So it is available. In fact, from MCMC's point or data, our mobile penetration is more than 100%, right? Mobile penetrations. So what it means is that a person can have more than 2 phones. That's matter, smartphones. That's what it means by more than 100%. But our normal internet connectivity maybe is about 80% plus, I think, if I'm not mistaken. Development has become so easy, right? Compared to last time. So we need to know the fundamentals of everything for us to build something. You need to know C, I mean, in terms of programming languages, you need to know C, C++, Java. Nowadays, it's kind of a plug and play. It doesn't require you to know the fundamentals. The tools are there, the environment, the programming environment can be set. In some cases, drag and drop, like no trade, for example, right? You know if, okay, drag the if, else, drag the else, and you can build a simple code. So similarly, it has become so much easier, right? And the technology that we are moving forward is called no code or less code, right? Moore's law still applies. Moore's law, so I'm sure you know Moore's law, transistors doubles every 18 months. It's still being applied until now, maybe until to a point where quantum computing comes in, maybe it will break the Moore's law. I'm not so sure. This is something that we can only see in the few years' time, right? Metcalfe's law, this is something related to connectivity. So what it says is the telecommunication towers, right? Telecommunication network is proportional to the square of number of connected users. It's practically what it says is that the more you add a telecommunication towers, a telecommunication network, the number of connected users will double, will square to the number. So the more you build, the more you have connectivity. So that's what it means. Now, because of all this thing that we have seen here, now IoT has become so much easier to be deployed, right? So this is the one of the reasons. Now let me just show, it may not be so clear because this is actually taken from a Time magazine. Now this is just to show the exponential curve of the technology innovation leading up to singularity. Right? So for example, the power of processors. Now, from agriculture revolution to industrial revolution, it took about 8,000 years. Industrial revolution to light bulb, 120. Light bulb to moon landing, it took about 90 years after that, right? So moon landing to World Wide Web took 22 years. World Wide Web to human genome sequencing, 9 years. So see the exponential growth here. The processing power that we have right now, so high, right? And then back in 2015, it seems that it surpasses brain power of a mouse. And we expect that it surpasses the brain power of human in 2023. I hope that, we don't create robots to overtake us, like the movies. We've seen so many movies of that. Sometimes a bit scary also. To see, I'm sure you have seen, robots, like dogs, like animals walking. Oh, so worrying. Imagine that we give the power to them to learn, right? Artificial intelligence, and they are smart enough to learn and then attack, like in the movies. Hope that would not happen. Right. So again, so this shows the brain power, right? So sorry, the processing power. Let's keep on increasing. All right. So, okay. So let's go back to our Nearpod, the same link just now that I've shared. This is the second activity. Okay. If you are in that Nearpod, let me just go back to the Nearpod. All right. The same link. Okay, so from your understanding, right, why do we need to connect things? Right? Connect things. Things here could be, I give an example. For example, it's a personal thing, myself, to continuously measure my personal health. So what are the other things that need to be connected? Why? In your opinion? Okay, you can share your thoughts. Right. So some have said, okay, to simplify things, right? To monitor remotely, yes, exactly. You want to see what is happening in your house, who has entered, and so on. To communicate through different devices, yes, for actuation purposes. If something happens, how do you send the communication to another type of devices? Easy to manage, save more time. Yes, exactly. In fact, what the purpose of you to connect things is that saves time. A good example will be in the industrial sector, right, where we monitor the machines so that it would not break down, right? You can predict when is the next cycle of maintenance and so on. To fully control it, more accurate postulations and prediction. To let everyone stay connected, yes. Communicate, save time. To be able to have communication, yes. It's good to have things automatically rather than manually done. Smart control system, yes, you're correct. You're correct. Right, so let's see why do we need to connect things, right? So the thing is that, see, there's so many factors or things that we want to monitor in our surrounding. For example, right, you want to monitor the vegetables, for example, or the fruits. So this could be in the hypermarkets or in the supermarkets or in the shops. What happens is, they need to leave it overnight. So what happens if the fridge stops working? How would they get to know, right? What is the optimum temperature need to be monitored so that the quality of the goods will always be there? Second, who's the intruder? Now, this is, of course, we have seen CCTV and so on, but what if we analyze the data, seeing whether, it matches? For example, in China, right? So I'm sure you have seen, China has so many cameras. They don't worry about privacy and all those things. They can just watch, see what you are doing. An example would be what they have given, and I've read somewhere, is that the analytics is so high, assuming that a person goes to a shop and buys, say, a sack, a rope, maybe a knife. And what they do is that they see the pattern of what they purchase and the background of this particular person. If he has a criminal record, then he may want to do something, he may want to steal something, that's how they relate things. But if he has a good record, then maybe the system would say, okay, this is a normal person, you can ignore it. So these are type of things that you can do, but this is, of course, high end. How can I reduce my electricity bill? Of course, you can monitor your house electricity consumption, either at the main source or individual appliances. So for individual appliances, there are some devices, right? So you attach a plug like, so you connect your appliances to that particular plug. It monitors your consumption. If there's an irregular pattern of it, that means something is wrong. So this is the electricity. Am I healthy? See, I've always see this, our parents, our grandparents, they don't really bother about measuring or knowing their health. They live a normal life. But again, we have the technology, right? We have smart watches. We have wearable devices to know how healthy we are, to know how many steps that we take per day, and all those things. So these all be used to measure our daily activity. And it's useful. Why? Because then we can predict it, whether in the future, say, assuming that this week you did, say about 30,000 or 40,000 steps. Suddenly next week, the following week, you only did 5,000. Then from here, you will know your activity has become passive. So this is information that we need to collect. Next is, when is my next bus? This is the big issues in Malaysia. I mean, not all the places, trains, buses, we'll be waiting and waiting and waiting for the bus to come. It will never come. And we would never know. So the purpose here is that to better plan our daily activity, right? So if we know, the particular bus will come, say, about 10:30, then we can go just before that. It's all preparing and planning. Where can I park, or where did I park my car? So this is just another thing. Now, I'm sure if you go to shopping malls or shopping complexes, usually in KL area here in Klang Valley, you won't get parking. Even if you get parking, it's such a multi-level. Sometimes you forget where you park. There's one mall in IOI City Mall in Putrajaya. What they've done is that they've fitted their parkings with many cameras. So many cameras. So you don't have to worry about where you park. You don't have to jot down or write down where you park. So once at the entrance, there'll be a monitor, and you just need to type in your car plate number. It will show you the image of your car, the photo of your car, where you parked it, and so on. So it's so detailed. So this is kind of, it is Internet of Things, but of course, it costs a lot because you need to deploy so many those cameras around, right? So like this, we need to ask, what if we can connect all those assets and get answers for all the questions? So this is the ultimate of IoT. So what's the benefit of it, right? Some of you have pointed out earlier, is to decrease costs, save time, improve efficiency, data for prediction, minimizing human effort, right? In some manufacturing lines, you don't, you don't set a periodic maintenance cycle. If you put sensors on the machinery, based on the data that we collect, we can analyze it to know how good or how bad is the machine and when is the next cycle for their maintenance. So this is for minimizing human effort. Customer experiences, better customer experiences. For example, you should provide a smartwatch that measures your health parameter. It provides a better experience for the users. And of course, performance and safety. Now, performance and safety, again, it could also be in the construction site. For example, you have a proximity sensor. So each person wears a proximity sensor. And whenever you are near to a machine that's moving or something, you'll get alert. So there's less accident. And in some cases, for for the towers, those who are working in the maintenance of the towers, sometimes they need to climb up. So if we have these smart devices, they would know the fatigue level of the workers, and so on. So these are all performance and safety. In fact, there are so many other benefits. This is just a sum of it. Let's look into paradigm shift of IoT. So why do we need to move on, right? So if you look at this traditional mindset and IoT mindset, in terms of addressing customer needs, is more towards reactive in terms of traditional, but IoT mindset is predictive. Again, based on the data that has been collected. Product offering, usually traditional mindset is a standalone, but IoT mindset is a continuous update. Of course, sometimes it's interchangeably, sometimes it can be applied for both. Role of data, you want to create user experience. This is a value capture. So how do we make profit? Advantage to provide improved capability. So these are some of the things that IoT mindsets, when we fine tune ourselves into IoT mindset, we always need to think about this. Now, let's look at the overall ecosystem of IoT. In fact, this particular section is important for us to build an end-to-end IoT solution. In general, this is taken from, Telecom Circle, and it's quite old, but it shows the entire value chain of IoT. This is a detailed part. The next one will give a simplified version. but this is a detailed part. It has a smart module, chipsets manufacturers, Intel, Gemalto, Qualcomm, and so on. Smart object is kind of sensors attached to device. So this is called smart objects. We have Bosch, Fitbit, Apple. You can think smart objects like the smart thermostat, right? There's a very famous smart thermostat. This is a smart object. Connectivity, of course, we have the connectivity, so I don't have to mention this. Platform, there are so many platform players out there, specific to a particular use case, or it's horizontal, so various types of platforms. And of course, software customization applications. So this is a very a breakdown of details of the IoT value chain. In general, right, IoT ecosystem consists of 5. Right, consists of 5. One is the device. Now, in the device, you can further break down into sensor device. Sensor device, you can imagine any sensors like temperature, you can say humidity, light sensor, proximity sensor, and so on. So these are all sensors. Second is the gateway. Gateway is an intermediary device between the sensor device to the platform, right? Or to send the data to the platform. And then we have edge gateway. The difference between these two, edge gateway has a processing capability or filtering capability. It can process data before it's sent to the platform. Process here means is that you can remove some data. You can send and triggers back to the sensors from here. Whereas gateway is like a forwarding device. It gets data from a sensor, it forwards it, that's it. Right?
Okay. The gateway is an example for the gateway and the edge gateway. Is it microcontroller or what?
No, not microcontroller. Microcontroller would be here in the sensor devices. Gateway is like, okay, I'll explain in detail later in the device section. Okay, and there's a slide on it. I'll explain that later. Second is that connectivity. So this is important. Connectivity could be short range, long range, and so on. In fact, each component I will explain in detail later. Next, we have cloud. Don't use the word cloud, platform. So we use platform. Okay, so device, connectivity, platform. And then we have application. Now for application, it could be a dashboard, it could be a mobile app, it could be analysis tools, and so on. So these are all grouped into application. And then, of course, the fifth one is the security and privacy that cut across from device to the application. So there are 5. Again, devices, connectivity, platform, application, and security. Okay, so these are the 5 ecosystems. And I will go through one by one on this. So this is the entire IoT architecture. This is taken from IoT Analytics. This is 2019. So here it actually divides the IoT architecture into the hardware level, communication level, software level, and application level. So now if you look at the hardware, there are various kinds of sensors, communication, actuator, processor, and so on. And then we have a communication level, right? So communication level, you have various connectivity, short range, long range, satellite communication, and so on. And then you have a communication protocols. The network protocol could be 6LoWPAN, IPv6, and so on. In fact, 6LoWPAN, if you know 6LoWPAN, IPv6 over low power wireless personal area network, it is using IPv6, but it's a shorter version of IPv6. That's what it's 6LoWPAN for. I'm not so sure why it's not being used widely, but it's there. A session protocol, so we'll be looking into a few of those session protocols later. Backend, software level, it's a middleware, database, processing, analytics tools, and so on. On top is the specific application that is applied. So consumer, business, various sectors and so on. And of course, security, as I mentioned, is cut across from device level to the application level. So this is just to show an overview of how all the components are connected. Right. So let's move to the source of data. We know that in IoT, the main source of data is sensors, hardware. But we can also get other types of data from other sources. One is crowdsourced, open data, and proprietary data. Now, crowdsourced means it could be from Facebook, Twitter, social media, and so on. So that's called crowdsourced data. Open data, there are some sites, there are some organizations who provide open data. It could be, for example, openweather.com. OpenWeather, they provide weather data that you can use their API to extract the data. This is open data. Proprietary data specific to organize. For example, if you go to Putrajaya, so Putrajaya Holdings may hold some data, the traffic pattern, the traffic lights, and so on. So that's called proprietary data, right? So these all are source of data, and we need to ensure that the platform that we use should be able to cater for these various sources of and format of data. Okay, again, this is the data flow, process flow. First is that in an IoT, you must make sure that an event, any happening in the physical world that need to be identified or observed. So if you, in the design thinking, you need to identify the problem. So based on the problem, you would know, what do I want to measure? Do I want to measure the vibration level of the machine? Do I want to measure the temperature or the humidity or people coming in and out of the particular room? So these are all events. And of course, for each event, there are different sensors. Now, okay, again, even for sensors, there are different quality of sensors. Take, for example, pH sensors. Now, pH sensors is a different level. If you want a very, very high precision, it's also available. Low precision, it's also available. So it depends on the application that you're going to deploy. Say you want to measure the pH of a water quality. Okay, drinking water, you must have a very high precision sensors. Similarly, you can use a lower level precision, say for example, in aquaculture. Maybe I'm just giving an example, right? So same pH sensors, but different quality. Next is that the thing detects events. So the thing, as I mentioned, sensors, it detects measure the physical quality. Once it's done that, it logs the data, register the data either locally, okay, it could be temporary, or it uploads it at the same time, it uploads to the platform. In our case, the platform. Then we analyze the data, and what to do after that is that we trigger action, we create report, analysis, prediction, and so on. So these are all the flow of it. Okay. Here, of course, the ultimate goal is a device with self properties. Self properties here means is that self configuration, self setting, and so on. Of course, this is much like robot, like AI. So you attach AI to it, it will learn. That's the ultimate, not necessarily. In fact, in IoT devices, there are the simplest one and also the more advanced versions of it. And of course, the other part of it. Okay, so let's look into the first part.
The copy, yeah.
Yes,
Can
please.
you go back to a previous slide? Where does a Favoriot company here get
So we
part?
are actually here, upload, we actually in the platform.
So analysis, how about analysis?
No, we do a simple analysis. We provide tools, we connect to third party. As I mentioned earlier, because domain specific, right? So we cannot provide all the analysis for different sets of data. We very, very fundamental analysis, minimum, maximum, average, and so on. So that can be done. But we are try to add few more analysis of it in the next version of the platform. Yeah.
Okay.
But specific to domain, we need to use a third-party tool.
Okay. Is it like a server?
No, it's in the cloud right now. Our platform runs in the cloud, but it can also run on premise as well.
Okay.
You can think it of a server, yes, but in the cloud.
Okay.
Now, so let's look in detail about the 5 components that I've mentioned, right? First is the device and the sensors. Now, getting data using the device. So how do you get the data, right? So from the sensors I mentioned earlier, then it goes to the processing unit within the sensor device, and which has the communication module. There are 2 types of those devices: basic, small in size, low cost, and consume low energy. Okay, why low energy? See, one of the concept of IoT in some is that it should run without human interference for years. So means that you deploy it in the field, you should run, say, for example, 5 years, 6 years, without the need to change the battery, right? So if you are considering that type of sensors, then the processors should be low. That means you cannot have a very high-end processor. And must be a mechanism how you reserve or conserve the energy. There are various ways. For example, in some cases, like Huawei, what they said is that the 5G network. So what they claim is that the IoT device can last for 10 years. Of course, there is a clause. How to get the 10 years, right? You only send data once a day. This is a non-critical type of an application. The sensor device wakes up once a day, captures the data, send it to the platform, and goes back to sleep. If you do that, yes, it's possible to last long. But in some cases, you cannot do that. You must continuously measure and send the data. As I said, so it depends on application specific, right? Next is the advanced one. So for the advanced type of sensor, which may have a better processor, which may have a better source of power, so you can actually do a self-adapting, self-configuring, interoperable communication, meaning that you can quickly change to different communication, provided that it has multiple interfaces, right? Integrated to different network. Now, for the advanced one, it must have sufficient amount of energy. It could be, say, for example, a solar panel or any other source, battery source, and so on. That's advanced. Because when you talk about self-adapting, self-configuring, the device was always in the listening mode as well to receive commands from the server, from the platform, and so on. Right? So these are 2 different types of modules. Now, this is just to show some of the development kits, right, out there. There's so many. In fact, over the years, various organizations have come up with different kinds of development kit. Now we have Arduino Mega, Arduino Uno, you have ESP32, Hibiscus Sense uses ESP32 chip, and so many. In fact, Intel has one, Intel has few actually, and a few others, right? So these are all development kit that they provide with their own API, their own SDK for us to install and so on. So Raspberry Pi and so on. So these are so many out there, right? So the purpose is what you want to do is for a fundamental learning, then you may want to get a cheaper one or a simplest one. See, for example, the Hibiscus sense that each one of you has, it has multiple senses, and it is sufficient for us to do a connect, a learn fundamentals of IoT. And the sensors, there are many, right? So many types of sensors. This is taken from an article, IEEE magazine, specifically on magnetic. But what they have shown here is that the proportion of usage of sensors, right? Temperature, moisture, flow, acoustic, chemical, gas, proximity, vibration sensor, tilt. In fact, these are just few. There are other sensors also. If you talk about water, right? Water, you talk about pH level, you talk about ammonia, you have turbidity, chlorine, so many things. So these are different types of sensors. By the way, do you know the issue, Kat Selangor, right? The water issue. Why do you think that we cannot use any of these sensors? See, none of these pH sensors and all those things, impossible, or it seems cannot detect. The reason being is that it's an order sensor, and this is a colorless order. Of course, in some cases you can detect, but what they do is that what they're doing right now, they take water sample, take it to the lab, and they do sampling and they smell it. Individually, they smell it, that's how they did. To know what they call that, I forgot the name of it. They must get certain level of that, and then only they can release it to the processing plant. So none of this pH sensors can work on that. But there's a big challenge that the Selangor. So many times they have water disruption and so on. Kapelis okay lah kan? Yeah. Okay. Okay. So in terms of sensors, right? Take for example your smartphone. Your smartphone is actually a sensor device, sensing device. Right? Why? Because there's so many sensors in it. And in fact, so many sensors are being added as well. Right? So we have a camera, we have microphone, because these are all input. Right? Accelerometer, gyroscopic, light sensor, fingerprint, GPS, magnetometer, motion, SpO2. In fact, there are also a research being done to measure your, the blood glucose level, right? Using infrared kind of a thing. In fact, Apple started it for their Apple Watch, but somehow, I don't know why they never released, maybe they have not completed their work and so on. So instead of us pricking, the normal method of getting the blood, and then they just use kind of an infrared and measures the blood glucose level. So based on the reflection that they get. So your phone is actually a sensor with multiple types of those sensing capability. So similarly, for different environment, different application, you may need different sensors. For agriculture, for example, so you have light sensor, temperature, airflow, dielectric soil, mechanical, electrochemical, and even for agriculture, we have aquaculture, we have a cabin-based smart agriculture as well. Now, if you talk about cabin-based, container-based, it's a very closed loop. You need to have, say, for example, 24 hours air conditioning. And so you need to measure the temperature, you need to measure the aircon, whether it's on or not all the time with the optimum temperature. You need to have the light sensor and so on. So again, it's different than the farm that we have outside, right? For example, chili. So to grow chili, you maybe need to measure the soil, what's they called, the solution, the mixture of the solutions, right, and so on. So it's a different sensors. Even though for agriculture, for different use cases, it is different types of sensors. So this is the wireless sensor map of a sensor device. This is taken from your development, from MEMS report. So here, if you notice, there's the energy storage module. You can have the lithium-ion battery or AAA battery or any batteries. There's also energy harvesting, either from solar or from any source, right, for that matter. So in order for you to store, so you must have a power management circuit, power management. So how do you manage the power within the board, right, within the circuit and so on? So you might have ultra capacitor, micro batteries and so on. Then we have a sensing module. So this is all the sensors. In some cases, like Libelium, for example, they provide one device, main device, and you can plug in different sensors. Okay, the sensors. Okay, so the device will just read it. So they do not attach the sensors. They do not inbuild the sensors, right? It's a separate. And then we have RF module. The RF module, it could be Zigbee, it could be Bluetooth, anything. So depending on the solutions that you want to deploy. So this is typically the, if you're into the hardware, if you're from electrical engineering, then you would know better all this connectivity and so on. Okay. So next is the connectivity and communication module. This is the second part, right? Second module. Now, this is where I said I will explain about the devices and the connectivity. So we have different types of connectivity. The first one is direct from sensor to the platform. Okay, meaning your sensor may be fitted with LTE or 4G SIM. So it's sent directly to the backend. Now, in this case, where do we use this? Use in a very, for example, farm area, or in some cases to measure the, how to say, the wildlife. And in some cases they measure the pattern, the travel pattern of a turtle. So what they did, they put the sensor on top, they fix it, the satellite will pick it up. So it's direct connectivity. In some cases, I think, if I'm mistaken, tigers and so on, wildlife movement pattern and so on. So this is direct connectivity. Second is the sensor to gateway to server. Gateway acts as the collector of the data from many sensors. So instead of this sensor having individual SIM cards, it could be a Bluetooth or a Wi-Fi connectivity to the gateway. Gateway receives it, pushes the data to the backend system using Ethernet, 4G, or any interfaces. So this is, so microcontroller would be here, right, at the sensor level. At a gateway level, it receives its forward 6. That is the fundamental of the gateway. In this case, so again, this is just one gateway to one backend system. Here, you have multiple types of gateways. So gateway 1, for example, can support only Bluetooth. Gateway 2 supports Zigbee. Gateway 3 supports, say, for example, different types of communication protocol, connectivity protocol. So it's a very specific, but all of those gateways can send data to platform in its own way. Okay.
Is it the hardware? The gateway is a hardware, right?
Yes. Gateway is hardware.
Like the hub.
Yeah. We can call it a hub, yes. Like a Wi-Fi, Wi-Fi AP that you have at home. So you can think of that Wi-Fi AP as a gateway. It does nothing than just forwarding the data to the backend. Next, we have gateway or edge device. Now, the difference between these two is this one have multiple interfaces. So it has, say, for example, Bluetooth here, it has Wi-Fi here, it has Zigbee here, and all different kinds of sensors can send data to the single gateway, which it will know how to process it. Because if you talk about Bluetooth and Zigbee, is two different formats altogether. So the gateway need to process the data and send it to the backend system. In some cases, the gateway has some module to process the data. Okay, so these are all the different types of connectivity, general connectivity type.
Means the gateway is the firmware inside for each devices.
Not on the device, not on the end device, not on the end device. End device, you're talking about, say, temperature sensor is together with, say, Wi-Fi connectivity module, right? It sends data to a gateway that sits in a building, for example. The gateway has a Wi-Fi module and a backend connectivity, Ethernet or something. So that's what it means.
Dr. Gopi.
Yeah.
If I give an example like an RFID system, like smart tag or the which part of this?
Right. So if you talk about RFID, right? So RFID, the tags, either passive or active RFID, is called sensing. It is here, right? It's sensing. The reader would be here. It reads, of course, even the normal RFID type of system, if it reads and store it within the system, it's not a gateway. In some cases, the RFID gateway are together. So they read the tag and then send it to the platform. So itu gateway dia. Even kita punya smart tag kalau you go in a highway, right? That reader is kind of a gateway.
Yeah.
Baik, kita pakai smart tag, pakai apa? Aktif lah kan?
Sometimes we confuse with the gateway in the internet connection. Our Windows here, that we have to set the gateway, right?
The gateway IP address. Yes.
What is that actually? I'm not very sure.
No, that is again similar things. See, you need to set the IP address, the gateway. See, when you set it up, you give an IP address, right? Right. If it is within your home, your wireless access point will act as a gateway. So you give that. See, that's why when you search, when you type IP config, right? You see the gateway. The gateway is the next point where it forwards your data out. Next interface.
Layer, is it?
Yes. A different layer. In your office, I think either each floor, each building will have one gateway that connects to the university's main network. So that gateway handles all the connectivity within that building. So it forwards it. So that's why it's correct. It's actually the same thing. Now, the communication challenges. Let's see the time. Right. Okay. Now, there are a few communication challenges specifically in IoT. One is that addressing and identification. You see, in IoT, the sensing device are small. I mean, the devices are small. Small in terms of processing power, memory, and so on. So you cannot have like a normal identification. You cannot have, for example, IPv6 to be used. Because IPv6 is 128 bits, it takes a lot of memory. So you must have a different kind of identification, right? It could be a predefined MAC address is already there, maybe, right? Second is a low power communication. Now, the higher RF that you have, or the RF setting, the high power that you need, as we all know, if you use LTE 4G, you need to have a specific RF power. And each time you transmit, it uses certain amount of power. So you need to ensure that the power usage is actually correlates to the application that you use. If you have, for example, Wi-Fi connectivity within that area, use Wi-Fi connectivity. If you have a mains power, use mains power. Again, depends on the range of transmission. The longer transmission range, the higher power it uses. Routing protocol with low memory requirement. In some cases, you may need routing protocol, but nowadays it is direct. I don't see that many solutions that uses routing protocol in an IoT solution. If you want to use, multi-hop kind of a routing, you can use that in some cases. Okay, high speed and lossless communication. Okay, again, we want to ensure in some cases the data is transmitted fast and data is not lost in communication. So there's a mechanism for it. Either use UDP or use TCP type of connectivity, right? Now, this chart shows all the different wireless technology in IoT. Okay, so this is from IoT Analytics 2020. So here you can see short range, you have medium range, and you have a cellular and satellite. Short range, there are a few, Zigbee, wireless HART. Wireless HART, Zigbee are all more towards proprietary protocol. Okay, Z-Wave, Bluetooth, Bluetooth 5, and then Wi-Fi. So here you see the data rate. Of course, Wi-Fi, you have higher data rate. Medium range, you have Wi-Fi Hello. It can go up to 1 kilometer. It's also Wi-Fi, but it's a new version of Wi-Fi. Okay, and then MBUS-7. And then if you look into a very long range, there are LTE-M, LoRa, Sigfox are the most used now. And then we have 5G connectivity. So 5G, one of the features is the inbuilt meant for IoT connectivity. Okay, 5G feature. And then we have VSAT. Now, for the past few months, I've seen two who have approached us in terms of the Wi-Fi. One is from France, the other one from Switzerland. So what they do is that they provide low orbit satellite connectivity, right? But the challenge, there are two challenges. One is the cost is quite high because you're talking about fitting, satellite types of connectivity. This one. Second challenge is that the number of satellites in the orbit. The one that from France, what they have mentioned is that they, the lapse, the time gap between two satellites is about 30 minutes, I'm not mistaken, 15 to 30 minutes. That's high, meaning that your sensor device need to be programmed such that it wakes up and sends according to that orbital, the pattern, the satellite pattern, movement pattern. If you miss it, the data will not be sent. So to reduce the time, what they are doing right now is they are launching more satellites to bring the time from 20 minutes, if not mistaken, to 5 minutes. So every 5 minutes, you will see one satellite above that particular sensor. So that's what it means. It's a very big challenge. It's a very expensive solution. But of course, it is meant for specific cases. For example, for containers moving on a ship, right? Wildlife, very hard to reach. There's no connectivity in some places. So that type of solution, yes.
For a medium range wireless, right? Then we need the monthly subscription like the LTE or the GSM like that.
For medium range, is it?
Yeah.
I don't think so.
FOC like the Wi-Fi, Bluetooth there.
It's not on your own. I think you need to set up on your own kind of a network.
Okay.
There's no. I've never seen a subscription for this one.
Quite good. So means kilometer range, right?
Yeah. Wi-Fi Hello is about a kilometer range. Dash 7 is also there, but these are all you set up your own.
See, okay.
So here you notice there are two types of long range technology. One is the non-3GPP standard. The other one is a 3GPP standard. Practically one is a license. The other one is non-license. Right. So license is this side. So in Malaysia, MCMC gives the license to this. This is a non-license. So non-license means that you can buy the gateway. You can set up your own. For example, take for example LoRa. You can set up LoRa, maybe 2 LoRa gateways for your campus, or 3, sufficient to cover the entire campus. Because it's a long range, it can cover up the entire campus. So that's how good LoRa is, right? And because it is a non-3GPP, you don't have to apply for license. But if you offer that as a service, you need to get a different license. It's an application service from MCMC. So that is the difference between these two.
What is mean by the service?
See, sometimes we offer that for people to subscribe, like you mentioned just now, right? Is there anyone for mid-range connectivity? Assuming I set up my LoRa network in my area, and I offer that as a service for subscription service. So for that, I need to apply a license. So this is the trend. So if you are working in terms of research, in terms of connectivity, so you may want to focus on, say, for example, LoRa and NB-IoT. So it account for 86% of the total LP1 connection by 2023. So this two is LoRa and NB-IoT, and of course 5G will also be there. The rest are there, but the progress is a bit slow compared to the others. So Sigfox Malaysia we also have Sigfox. What's the company's name? I always forget the company's name. Okay, so the difference between Sigfox and LoRa, anyone can buy and deploy. Okay, but Sigfox is only one company which is authorized to deploy and provide the service. The data for Sigfox goes all the way back to France because there's a main server there, and you can extract the data from there. Whereas LoRa is slightly different. Okay, so this is the difference between this. Sigfox is what's the name? I forgot the name. Okay, so this is just the stack. Networking communication layer stack. I've shown earlier the overall architecture, but this shows the IoT stack and also the web stack. So the most important is this part. This is just some examples. This is a wireless sensor. 15.4 is a wireless sensor. And then we have a 6LoWPAN, IP routing on top, UDP, CoAP, MQTT as an application layer. Then we have JSON. We have another one called CBOR. CBOR is something like a JSON. It's a binary data serialization format. And we have IoT application and device management on top. So this is about the second part of it, which is the connectivity. Okay. So shall we take a short break? So now it's 10:35. Say 10:50. 10:50.
Okay.
All right, so we shall resume at 10:50 then.
Okay, thank you.
Okay, no problem.
All right, thank you. Thank you.
Thank you.
By the way, if you have any questions, do let me know. Just think of any question that you have along the way. We'll try to discuss about it, right?
Yeah.
Okay, so we will move on to the third component of an IoT ecosystem, which is the platform. Now, there are various types of platforms out there. In fact, if you know about platform, I think there are about 1,000 different platforms, right? So how to differentiate these platforms? One, you can say it's a publicly traded, it's a big organizations. AWS, IoT has it, IBM has it, Google has it. So these are platform developed and maintained by large companies. And of course, even though they have a capacity to provide most of the features, but sometimes there's a trade-off in terms of the customization, specific need by the smaller organizations. And this is a publicly traded. And when we request for some changes or some updates within the platform, it's a bit difficult to get or for them to entertain you. So you just need to wait for the next features to be added. So this is how it goes. Second is the open source. Now, open source, there are quite a number. So if you see things like car and so on. So open source, there are two modes for it. Even though they provide open source, but sometimes it's a limited functionality. And they provide support if you subscribe to their service. Right, so the famous one is car and ThinkSpeak. Then we have end-to-end connectivity. End-to-end connectivity usually by telecom providers. You know, Cellcom has one, Maxis they also have one. So this is all based on the connectivity, telecom providers. And then we have developer-friendly. Now, developer-friendly, in this case, it provides integrations with any hardware. Any communication protocols, the standard communication protocols. So there are few, for example, carriers, Snowmo carriers is bought over by another organizations, and then Favoriot is just one of it. It has tools to create, source codes, many things. So in the architecture, right, in any IoT platform, these are some of the standard architecture, standard features that's available. Now, on the bottom here is devices, things, applications, and other systems. So devices here, like I mentioned earlier, the device measuring temperature, the gateway. So all this will come here. In this box, it is all the features. It is not a must-have, but usually it will be in the platform. Communication API interface. Now, what is this? In order for a third-party device to send data to the platform, they must use some kind of a predefined APIs, right? Each platform, they have their own sets of APIs. For example, REST APIs, MQTT type of communications, and so on. Now, this API need to be used in these devices for them to send the data. So this is called a communication API interface. Okay, as I said, each platform will have their own sets of APIs. Next is this feature is called edge interface, message broker, and message bus. Because most platform supports multiple types of communication. It supports MQTT, it supports REST, it supports CoAP, In some cases, they support different other protocols as well. In order for the platform to manage the different sets of data, so it needs to have a proper edge interface. In some cases, separate ports for all the different communications. And all this will be handled by the message broker and message bus, which will then channel it to either message router or communication management. So this way it will say, okay, this is from MQTT, this is for this particular device, you put it here, for example. So that's what it means. So it all manage the routing of the data within the platform. Then we have time series storage and data management. So this is kind of thing you can think it, or you think of a database, right? Most platform will have the database within the system. Very rare that they'll have a separate databases within the system. It could be as simple as SQL, but for IoT, the best is that the flat database, which is meant for large data. For example, MongoDB. You can think of Cassandra or any other similar types of databases, right? Favorite platform, so we use a Cassandra types of database. Then we have rule engine. Now, rule engine is a set of rules that you create for the data that arrives. For example, you say that if temperature is above 50, send email to so and so. So that is a rule. So similarly, this rule engine will take care of all the data stream that comes into the platform. And again, rules could be either specific to data stream, to specific to the device, and so on. So this is rule engine. Device manager is how do you manage the end devices here? It could be setting an actuation. In some cases, there are features where you can upgrade the firmware from the platform. Okay, provided that the device has the capability to receive data from the platform. And not all devices can do that. So this is device manager. In some cases, you can temporarily stop receiving data. Here you can delete data and so on. Sorry, delete the device and so on. Application is a user management. It's actually the portal itself. The favorite platform portal, which we will see later, is actually this. Then we have something called microservices. Microservices are add-on services that is being applied, that is being offered by specific platform. In some cases, SMS services, payment service, social media, verification system. These are all add-on service will consider as a microservices. So it's all small services you can plug and play. Okay, so these are microservices. So now on top of that, if you notice on the top here, this analytics tools as well as dashboard and application. Now for analytics tools, as I mentioned, in some platform, it is within, that means they have some basic analysis, but most often they have a separate tool that you need to integrate. Either you download the data from the platform, use a tool, or you can directly send the data to a third-party analytics tool from the platform. Dashboard and applications, sometimes the platform has a dashboard module, sometimes it won't. Like favorite platform, we have this, this. This, we don't have high-end analytics tools. We have inbuilt dashboard. We have all those other things as well. So this is some of the features of a generic features of an IoT platform. Okay, so if you want to build an IoT platform on your own, you can, provided that you find out. You see, some of those features are already available as open source. You can just, but you need to know how to integrate it, right? For example, communication API interface is there, microservices, SMS integration is there, all is available. It's just that sometimes it will take time for you to integrate. You need to understand the functionality of it and how you can integrate with the different components. Right. So next is let's move on to a short activity. Again, just a feedback. Let's see. The same, we use an airport. This time, what's the question? So daily use cases, you know, you'll be interacting with so many things daily basis. What are the daily use case that IoT can be applied? Maybe you want to mention the use case and also the benefit of it. Okay, benefit of applying IoT on the daily use cases. Now you can imagine from the day you wake up, you go to office, there's interaction, right? So what do you think some areas that IoT can be applied to improve the service and so on? Okay, I give a few minutes. You can send multiple answers. Everyone, are you all from electrical engineering? Most of the first three answers are all about electrics.
Electronics. We are from, some of us from electronics.
Okay. Okay, so these are your
Hi, Dr. Gopi.
yeah.
Yeah, sorry. Before that, can I ask a question?
Yes, can.
Actually, you talked about API before.
Mm-hmm.
I may have missed the explanation on the APIs actually.
Mm-hmm.
Can you explain back the function of APIs, and is it HTTP or MQTT? Is it the protocol that is sit in the API is actually the interface for what actually? I'm very confused on that.
Right. See, API stands for Application Programming Interface, right? It has a set of, I would say, predefined. Think of it as a function, a predefined function, right? So you must use that type of function which is predefined in order for you to send data, in order for you to retrieve data. For example, we will use those API later on. We'll explain that. But say, for example, you want to send data from the Hibiscus Sense to Favoriot platform. Of course, the communication protocol is REST, right? HTTP over REST. But how do you want to send the data? How would the platform know that you are sending data?
Platform means that the Favoriot IoT or
Yes.
ThinkPeak, something like that.
Yeah. Favoriot platform, Favoriot IoT platform. Now, Favoriot IoT platform has a set of APIs. Now, you must use POST to send the data, right? In the platform, we will see, okay, this is POST, this is a data structure for it, and this is how it is formatted, and the platform would know all those information and put it in the database. Similarly, it will have, for example, a delete, it will have update, right? So these are all kind of functions that's defined by each platform. I will go through these APIs later, most probably tomorrow, okay, in detail, explaining about this APIs application. But you can think it of as a function, predefined function provided by the platform providers.
So each platform, for example, if I use a free platform like ThinkSpeak before, they
Yes.
have
Their own
their
API.
own APIs rather than Favoriot IoT.
Yes,
right?
yes.
So
yes, correct.
the information, where can we get? On the
Usually
platform.
in their documentation they are there. Memang dia ada dah.
Oh,
Like ThinkSpeak, they ada their own documentation. Favoriot platform, we have our own documentation. So you can always refer to all the documentations.
Okay then, okay, thank you.
I will show later for Favoriot platform where to look. It is similar for all the other platforms as well.
We cannot regard MQTT or HTTP as a API, right?
No, MQTT is a
different.
MQTT is the communication protocol. Now, how do you use? How to say? Like TCP/IP and all those things, right? It's a standard protocols.
Yeah.
But functions or APIs like a function, how you send the data? How would the platform know that this is the data that you are sending? That is all defined in API.
Okay, understand.
Okay. So I will show the APIs later, so you'll have better understanding of it. Okay, so these are some of the your feed input. The first three is about electric, smart home, energy efficient, electricity usage, can control the bill. Yes, I think this is it Alexa? The one, the picture? Not so sure if it's Alexa or not. Something like that, I think. To notify letters on a pigeonhole. Yes, that's interesting. If it's pigeonhole somewhere far away, you can always get notification It's the letter. Home portable greenhouse, sensing soil, nutrient, moisture, temperature, watering. Yeah. In fact, there are so many such solutions available for urban farming. A smaller version of urban farming for house. So you can use that. Farming, yes. Agricultural control mechanism. Daily health monitoring via smartwatch. Yes, that can monitor your daily routine. In fact, Favoriot, we did offer the smartwatch 2-3 years ago. So we started off for elderly people to measure the location, the heart rate, the blood pressure, and the ECG. This is not a medical grade, it's a consumer grade device. It's a variation about 20% from the medical grade. So these are a number of steps as well. So, and then we move on from the elderly people to those who goes pilgrimage, Hajj, and so in Mecca. So we offer that. Of course, for the past 2 years, nothing, no pilgrimage event.
So it means you receive the hardware data from any kind of the smartwatch, is it?
Yes, smartwatch. Yeah, no, not any smartwatch. We have an OEM device, a smartwatch. We are not doing that anymore because the smartwatches, changes so fast. But smartwatch that we use has a SIM card. That's how it sends the GPS location, sends the heart rate, and so on. So we capture that, and each user will get a mobile app, will get a desktop app, so the family members can monitor as well, and so on. And you can set a geofence for the user. For example, if he moves out of particular geofence, you get an SMS alert, a message, and so on. So this is how smartwatch works. Okay, home monitoring, CCTV for security purpose, yes. Energy harvesting, yes, I think, yeah. Home energy harvesting is already there. This is like a Fitbit, okay, smartwatch. Brushing teeth habits, like sensor, noise, when you brush too hard, and proper time management. For brushing so difficult when you have bleeding, yeah. This is a smart brush. In fact, I've attended this one invention training. Not so sure what was trees invention. This was a few years ago. So there's an evolution of a toothbrush. If you notice, the normal toothbrush, and then the changes in the bristle. There's a holes. There's an active toothbrush. The toothbrush that measures how long you brush. So this is an evolution of inventive steps. It's very interesting. So this is something like that. Toothbrush that collects data, how long you brush, where you brush, and all those things. But some cases, it is good to have, but it is not profitable. It's not how to say, it's not optimal for the businesses. Watering the plants, IoT can set timer. Yes, this is something not bad, right? Okay, so let's go to application. So the reason why I asked is that it's related to the application, which is the fourth part of the modules. It is application. Now, if you look at the IoT top application, this is from, again, IoT Analytics. So they did a sampling of 1,414 projects. Again, this is 2020. So they've noticed that global share of enterprise IoT projects, 22% consist of manufacturing industrial sector. The trend here means is that the trend from 2018 to 2020, so it's upward trend. Transportation second, energy, retail, cities, smart health, and so on and so forth. Some are in the downward trend, but it may maybe because of this COVID and so on, it goes to downward trend. But most of it has actually moved upward trend. Some are active. In fact, if you look at the agriculture, I would say now, I can confidently say agriculture is definitely an upward trend. All right. So this is the application. So This is again one example of IoT for healthcare. In this chart, you can see that you can measure, as I mentioned, your health, your daily activity, the number of steps that you take, your heartbeat, your heart rate pattern, and so on. And in fact, once you have all those information, you can actually share that information to your doctors from a regular basis. We are not there yet in terms of, collecting this data and sharing with our medical doctor, right, on a regular basis. We don't do that. But in some cases, in each areas, for example, sports, right, you need to collect that information and share with your, for example, in soccer, right, football, they do collect all this information. In fact, every time they run, they take a blood sample, they see the glucose level, they see some other parameters within the blood. So these are information they collect. In fact, I know I think in Malaysia, I think they did a trial for hockey, right? So they fit the players with some sensors, and they want to see their activity level, their heart rate, the fatigue level, and many other things, right? So similarly, healthcare is a huge thing, from collecting to ambulances to connect to the healthcare management system, doctors who no more visits the patients regularly, they can remotely monitor them and only goes if required, and so on. So it is changing, but in Malaysia, it's changing in a slower pace. Okay, we are moving, adapting to this automated kind of solution. Now, smart pill. Now, this is something interesting, right? So, smart pill is actually, this was, I can't remember, 2014 or 2015. This is an FDA approved. This pill, right? This pill is a high-tech pill to screen colon cancer. But now I think they're using it for different purposes. Now, why is it an IoT, right? You can see it has a camera. There's a camera. It is a small chipset, antenna, sub-gigahertz antenna here, and they have batteries. So the person who want to monitor, you want to capture all the pictures that the pill will traverse, the moves, the stomach, large intestine, small intestine, and finally it goes out. So along the way, what it does is that it takes images, photos. It takes the photo, and there's a small patch outside. The patch is connected to either your mobile phone or a particular system that collects the data and analyzes. Now, what does it analyze? It analyzes the image that is taken when it goes, right? And it's quite a number of images. Now, so why is it revolution, right? It's different. So it's an 8-hour journey through the body. It's less than 4 grams. And the normal colonoscopy costs 4,000, but the pill only costs 5,000. The results almost identical, right? You don't have to go through, the hassle of the tube being put inside your intestine. Of course, you would not know because you'll be an anesthetic. So again, this is one of it, right? This is one of it. Again, as I said, it's not only for to detect colon cancer, but also any things related to your intestines and stomach. The good thing is, of course, it will get flushed out in a normal way. So that is the thing. This is called smart pill, and it's FDA approved. I'm not so sure if it's available here in Malaysia. Maybe it is. I'm not so sure. Okay, so this is another application. specifically on the agriculture. I mentioned it earlier. In some countries, they use drones, agriculture drones. The purpose of the drone is to fly over the farm. There are two things. One is to spray chemicals, pesticides, and also sometimes they capture image of the leaves, right? To see whether the leaf color, the leaf texture is good or not, and so on. So this is agriculture. Livestock tracking and geofencing. This has been used. I know in Australia they've used it. Not so sure in Malaysia. This is particularly, see, in Australia, it's such a huge farm area. So they live, the cows go around, to feed themselves. So they want to track all these cows, not only location, but in some cases, the health as well. And to ensure that they do not move out of certain areas. So this is through geofence. Smart greenhouses, predictive analytics of smart farming, container farming is a new thing. You can actually rent or can buy a container fitted with sensors and so on. You can start grow vegetable. Usually it's a leafy vegetable. Hydroponic and data collected by smart agriculture. So these are some of the how to transform the agriculture sector. So this is again agriculture. Now why is it important to identify the component, the devices, the connectivity? Is agriculture in some cases, for example, paddy, it covers say about 10 hectares. In the 10 hectares, you cannot have a Wi-Fi connection. You can have maybe a LoRa, Sigfox, or for example, the SIM card, right? LTE connectivity. And the type of sensors that you deploy. Is it to measure the moisture, the temperature, the alkaline, the soil pH, and so on? So it is important to identify all these components before we deploy it. Okay. So another example is for smart building. Right? So in smart building, you can have vibration sensor, you can have light sensor to automatically adjust the lighting in certain area. For example, if your meeting room is fitted with a light sensor, it will automatically turn on when there's a people inside it. Facial recognition, we have seen this being used. Access sensors, door access sensors. In one of the meetings that I've attended, this was a few years ago, they have sensors to detect. See, instead of, this is a standard meeting that I've attended. So they want to know the number of people in a particular room. So instead of us writing down the names, we are given badges. And once you enter the room, it automatically picks up, your name as an attendance. And it can actually, do some basic analysis, how long you were in the particular room for the discussion and so on and so forth. Gas sensors, I also in Malaysia, so we have in some places this is specifically in toilets. So instead of us or the facility management to do a regular maintenance, for example, the cleaners will go every hour in some shopping malls and so on. They do every hour to clean the toilets. But instead of doing that, if you have some sensors, for example, it could be access sensor and gas sensor. Access sensors to count the number of people goes inside the toilet. Gas sensor is, of course, some order that you can detect. Based on these two, you can actually analyze and say, okay, do I need to do the cleaning now, or maybe after 2 hours or something like that. So instead of every hour, is based on the condition of the toilet. So this is one example. In fact, there are some use cases here, I think, in Malaysia. Motion sensor, temperature, humidity, and so on. So all this, how does it connect to the platform? Using the APIs, okay, using the APIs to send the data, you build dashboard, and also you do actuation for that purpose. As I mentioned here, maintenance and also for cleaning purposes. All right. Now, so you have collected data. What to do with the data, right? There are different stages of analytics. In fact, there are 4 stages of analytics in IoT, starting from descriptive analysis, which measures or analyze data to learn about what is happening. For example, if you set a temperature sensor in your room, what is happening here means is that your temperature. It's straightforward. You get the data, say your temperature now is 25, tomorrow is 30, and so on. So that is what is happening. You collect the data as it is. That is called descriptive analytics. Next, using the data, this is called diagnostic analytics. Use data to analyze to answer why a problem is occurring. Okay. Example just now, say for example, the toilet example. If you notice, if you know that, the gas level, right? If you're assuming the gas, certain gases is high, why is it happening? Is it because there are many people using the toilet, or it is not cleaned regularly? No, these are some of the examples. Or there's no ventilation, for example. So you do some kind of basic analysis to understand why a problem is occurring. The next stage is what will happen. It's called predictive. You're predicting what will happen based on the data that you have collected. See here? Use past and present data to forecast and create models, allowing business to make prediction about the future. Same for your smartwatch, right? You collect your health parameters, and you would know the pattern. For example, if you see your heart rate today is a bit, off, the system will analyze. It will say, hey, something is going on with your heart rate. So this is called predicting based on the previous data sets that you have. This is predictive. The last one is prescriptive. Now, for prescriptive is that what should you do? Use data same like predictive, but you create a model and do a forecasting before it happens. Again, for prescriptive, it uses the same data sets that you have. You create a model based on that data, and then assuming this type of data that will be applied, what could be a potential outcome? Okay, so this is a different thing, right? Predictive is use the data, you predict what will happen. This is you create a data model and forecasting to test the likely outcome. Right? Again, the same example for smartwatch. You've collected the data, you've created a model, then you provide some input. Okay, this pattern, I've walked this many steps, this is my current heart rate. So what would be likely outcome? So that is what it means by prescriptive. Again, as we move from descriptive to prescriptive, the difficulty level increases. Here, straightforward, there's no analysis. You read the data as it is. You analyze a bit here. Here, you need to know what data that you want to analyze, how you want to analyze, and so on. Here, prescriptive, you need to create a model, right? The model is specific for that particular use case. It's very difficult, right? And then the value, of course, the higher it go, the higher the value. Most big data analytics companies have this expertise. Just how they can, their services are very expensive because they know how to make use of the data to create this predictive and prescriptive type of analytics. If the last slide that I have, I will show how the big data analytics is actually one of the highest sought after job right now, actually.
Like the Shopee,
yeah, exactly. Shopee, or if you go to certain sites, right, automatically you get picked up by Shopee or Lazada. You know, and then and then it will give you choices based on what you have searched. So there's actually,
sometimes I feel they listen to us, what we talk, then they know.
Exactly. No, they will know. In fact, my friend mentioned earlier, I mean, he said he went to, he went to a hospital for a checkup, right? And then when he searched, it says that the last place, he says something else, I think, and immediately something, it shows that your last location was at this place at this time and so on. So very scary that, you know, you've been tracked all the well, that's how they make money anyway. So if you're smart enough, you make money on that. Okay, so the last part of the component is the security. Remember, the first one is device, second is connectivity, third is platform, fourth is application, and the last one is the security. Like any security or system or issues that we have, like even a normal laptop, desktop, you will definitely have, you know, antivirus. Why you have antivirus? Because to avoid all these bots, the viruses, malwares, and everything. Same thing. IoT devices are no exception because they're connected. They also can be compromised. There were three major attacks that happened. The first one is the Mirai botnet. Second is the Virex. The third one is the Reaper. The first one, what it does, it attacked all the major sites using the IoT device, the compromised IoT devices, to launch a DDoS attack. And if you notice here, so the largest DDoS attack ever was launched on service provider. This was 2016. It's called IoT botnet. In fact, initially the botnet was used for some other purpose, I think for game related thing, and they reused the botnet to attack using the IoT devices. In fact, the Netflix, Guardian, Twitter, Reddit, and CNN was down for some time. This Mirai botnet. So imagine if you are talking about billions of connected devices, see what they can do, right? You can launch a DDoS attack using those devices if it is not properly secured, right? Same thing here, right? This is just an example. You can go and type a JPEG. There's a nice video about it. There are two, how to say, the two videos, I think. One is a JPEG, the other one is, was it a BMW or something? So what they do, these two hackers, they want to show that these cars, the Jeep, can also be hacked. They sit in their house, and of course they told the driver beforehand what would happen, right? So this driver was driving on a highway. No, right, in the video you can see the highway, right? They're driving, and they have total control of the car. The speed, the brakes, the movement, the air, the everything. The signals, the wipers, everything they took control. And the driver couldn't do anything. So that's how. So what actually happened is, these cars are connected to their infotainment system, to the infotainment provider. For example, this Jeep is connected to their infotainment by the provider, the Jeep. Because they're connected, so the hackers gain access to the infotainment and then take control of the CAN bus of the vehicle. So that's how they get control of all those things. So the example here is to show that even these devices can be hacked, right? So that's how, why is it important? In fact, in 2018, at the biggest cybersecurity event in US, so they have specifically discussed in length about the IoT security and what would happen if we did not, properly secure. So, for example, IoT security flaw leaves 496 million devices that time, right? At business. The future of either state-sponsored attack. You have read of the nuclear plant in Iran, right? So the nuclear plant which was hacked by just gaining access to a particular system. It's not sensor for that matter, but system. So similarly, this device can be used for that particular purposes. And the cost of attack is not cheap, right? So every time there is an attack, there's a huge downtime in terms of the businesses, in terms of getting back the system. It's big. It's big. So when we consider the security aspect in the IoT system solution, let's ensure that the constrained devices are secure. So why I specifically mentioned constrained devices, as I mentioned, most IoT devices, they do not have high processor. And because of that, you cannot have high encryption. So it's a trade-off. It must have security, yes, but secure enough to avoid any attack or being compromised. Authorize and authenticate the devices. Those devices that you deploy must be authenticated by a system. Manage device update. Now, this is a big challenge. This is a big challenge. If you say that you want to deploy IoT device, say in the farm, right? How often would you go and manage it? See, most of the time you deploy once, that's it, right? So, but then how do you update the firmware? How do you update this patches to it? So this is something, again, is a trade-off kind of thing. Sometimes you need to, do off the security is just once. There's no patches, there's no update, but it's secure enough, something like that. Okay, secure communication is another one. The end-to-end communication must be secure using HTTPS, TLS version 2, 1.2, and so on. And then the fifth one is that, is there a mechanism for us to detect the vulnerability or incident? See, these devices are connected to a network. If you cannot secure the devices at the device's end, you can actually secure at the network level, at the gateway levels, because gateways have better processor connected to power, so they can actually secure at that level. And you can detect any vulnerability and incidents. The sixth is how to manage the vulnerabilities. Again, how do you update the patches, update the firmware, and so on. So these are some of the issues that we need to consider when we deploy an IoT solution. So these are some of the fundamental questions that we need to ask in a good design. The first one is that what set of best practices is there? Questions that we need to answer. Lesson learned from security problems. Cost versus security trade-off I mentioned earlier. How do we quantify the access risk? It's a metric for it. Regulation. So we do not have any regulation in Malaysia yet, but we are proposing a consumer or baseline security for consumer IoT devices. Now, what that means is that any consumer IoT devices must comply this baseline security. In fact, Singapore has started it. Some European countries have started it as well. Okay, so there's a standard baseline security. Who will do the testing and so on? This is a secondary issue. Like Sirim, for example, if you give any devices that have connectivity or communication module, you must give to Sirim to be certified. And similarly, there should be a body that actually measures all these security standards. That's what we are proposing. Let's see how it goes. What is the right approach to take with obsolete IoT devices? Now, some devices have a lifetime, right? It's 5 years, 10 years. So what do you do with the devices? Most often, if it is not connected, you just let it die there. Of course, it is actually bad for environment, but that's how it is deployed, right? In some cases, it's self-destruct kind of a thing, like a Mission Impossible movie. They give a device, after 1 minute, self-destroy. Maybe something like that. Never know.
Yeah.
Right? Right. Okay, so again, because the importance of security in the National 4IR policy is stated, the importance of focusing on IoT. So this is the S12 strategy, initiative 25, we say here, enhance the existing cybersecurity framework by incorporating safeguard measures, blah, 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 with the focus on IoT. Okay, this is what the experts have put it in. Again, the first phase to be completed by 2022 is more towards awareness and adoption of the security part. So what do you think would happen if we did not properly secure, right? So you may have these machines, smart enough to ask ransomware and all those things. For example, you say the next time you leave, it will cost you 75 bucks. In fact, now you have seen, right? Use Bitcoin ransomware in order to unlock your laptop, your computer. They ask you ransomware. It's happening, right? So how long that it will take for them to hack all those things here? It is, see, the technology is good, promising, but at the same time, it's quite worrying as well if you look into all the aspects. So that's the reason why it is important for us to have a proper end-to-end design so that you can properly secure all the systems that we have. Right? In one of the Mirai botnet, if not mistaken, they hacked the refrigerator. In some cases, they go to the refrigerator and then they go to your fish aquarium. There's a sensors in the aquarium, so they take control of the aquarium and then attach the DDoS attack. This was reported in one of the papers. I can't remember which paper. So this is a different way of hacking. And what is the most common issues? The most common issues of the security, how they get access, is your username and your password. Your password is password. Your password is 12345. When you buy off-the-shelf devices, especially from China and so on, right? You buy these cameras and so on. People they don't change this password. They connect to the network and people can see. In fact, there are two sides. I forgot to actually, I wanted to share that. The two sides, one is the IoT, what's the name? Okay, so this side, go and find all the devices that can be accessed, by this one, by this password. And they've listed all those devices. The second side is CCTV, cameras. But luckily, they only show all the CCTV on the streets, not in the room and all those things. It's true. You can see the real feed in all the CCTV simply by getting the IP address, accessing by the default password. That's it. So that's the biggest challenge that we have with these devices. What's the activity? Hold on. We have okay. So they have a short activity. So just a simple 3 questions, I think. You may want to attempt the questions. Hold on. Okay. So I will go for a short break while you take this question. Okay, there are 3 questions only. Well, you may think this question may come up in your exam. Can you see the question? In airport.
Yeah,
right?
yeah.
Okay,
Yeah.
okay, good,
Yes,
good.
yes.
Big question,
Okay,
right?
okay. All right. 3 questions only. Okay. So you're done. Okay, let's see. Now, the first 2 questions is a bit tricky. Tricky in the sense of the answer is IoT solution or not an IoT solution, right? Now, when you say IoT solution, right, it must comprise of all the components. I mean, of course, security is exceptional, but it must have device. Is it sending, is it collecting data? Is it analyzing the data as an application of it? If it say IoT device, yes, those first two questions, yes, it is an IoT. If it says IoT device, if it says IoT solution, is it Acon, right? The first one is Acon, right? Is it Acon? So I can't see the question here.
Wi-Fi ready icon.
Wi-Fi ready icon, yeah. So the first one is Wi-Fi ready icon, but it doesn't say that it has an application that you can control it, from a system and so on. So it is not an IoT solution. It's an IoT device, yes. Right? The smartwatch, yes, is an IoT solution because it says that you collect the data, you send it to the platform, you analyze it. Of course, it doesn't say all those things. It has an applications and so on. So there's an end-to-end. Okay. The third question is the IoT ecosystem. Only the 5. I've repeated that many times. We only have 5. The device, the connectivity, platform, application, and security. Okay, so these 5 consist of the IoT ecosystem. All right, good. Almost 50-50. Almost 50-50 on your answers. Right. Okay, so let's move on. The next part, because the first one that what I mentioned earlier is about the IoT ecosystem. Is it cyber attack? Sorry, I missed the one. Is it cyber attack? Is it for which one? I missed the one. There's a question, is it cyber attack? I'm not so sure which is the question for. Okay, so never mind. So let's look at the computing types in IoT. Now, there are various definitions, the explanation given in terms of the computing types. In here, you will notice that there are 4 main parts. Mist is the lowest at the device level, right? It's called MIST. Lightweight computing and local decision making. It has a kind of decision making at the sensor level, at the sensor device level. Usually, it's for critical kind of application. Okay. Say, for example, in a factory, right? Machines, right? Machine. You will know if you put sensors to it, if something going to happen, if the sensor detects it, immediately the sensor can trigger something to stop the machine from running. So instead of sending the data all the way to the platform and wait for their action, we can do that simple processing at the MIST level. This is called MIST. Okay, so if you see here, the processing speed and response time is much faster to the lower level. Next, we have edge. I've mentioned earlier, it is at the gateway level. It can process data based on application. You can think of autonomous car as an edge gateway because it has so many sensors to it that collects and makes quick decision. You don't say in autonomous vehicle, you cannot be sending data all the way to the platform and return, wait for the supply. By then, accident would happen. So it's all the decision takes place in the car itself. And at the same time, it also sends data to the platform. Some process data is sent to the platform for further improvement of the system. Okay, so this is edge gateway. Fog. Now, fog, the term fog was actually proposed or coined, introduced by Cisco. Fog is something like a cloud level, but they bring it down nearer to the solution. Okay, it can have all the capability of a cloud, but they bring it closer so that it reduces the latency, it reduces the storage in the cloud, because you do the filtering here. You do the data filtering and only important data is sent to the cloud to be registered. So this is a small distributed data centers provide resource dense midpoint between edge device. Low round trip time latencies. Again, some less critical, so you can put it in the form. And of course, the last one is the cloud. Okay, so this is the computing type. So these are the comparison of, so these are the comparison between fog, edge, and mist. Again, fog, you extend the cloud to the edge of network. It's a decentralized, any device with sufficient resources. Resources, it means that it has processing power, it has storage to store the data. Of course, sufficient connectivity as well. Edge, I've said this again, it's a gateway. So between the end device and the fog or cloud, it has a data processing and local storage as well. Very small data storage. Mist is just the end, right? The sensor level. So it has some processing power and lightweight computing. Again, not all sensors are mist in this category. Some sensors just collect data and send it. They don't do anything. That is why the actuation or response to a particular situation can happen at different level. At the mist level, meaning at the device level, that is for very, very critical types of solution. Can happen at the gateway level, right? The gateway process and send the response. Can happen at the fog level. It can happen at the cloud level or at the platform level, or it can also happen at the application level. At the application level is a very non-critical type of application. Okay, you process the data, you analyze, right? And then only you trigger something. That's application level. So these are the different levels of you processing the data. Yes.
The cloud and the platform, is that the same?
Right. Now, cloud is the physical system, right? Cloud consists of all the hardwares. Platform sits in the cloud. Okay. Platform has many functionalities, features, as I mentioned just now. Cloud is a physical infrastructure. That's the difference. Okay. So let's move to.
Sorry, about the mist. Apa yang I faham jelas for my understanding is a sensor that can make a decision, kind of small decision.
Yes.
Like macam kita ada jam like jam G-Shock. It's not smartwatch. It's a G-Shock that have a barometer sensor to send the pressure, whether it's going to be rain or hot day. So is that considered IoT or somehow?
It is an IoT device, but it's not connected.
Yeah.
If it doesn't do anything. It gives you the barometric pressure. It gives you the data, but you need to interpret on your own.
Okay.
If it sends the data to the platform, or it has some processing that it can interpret to you, it can be considered as an IoT device.
Okay. Thanks, Doctor.
Right? Okay. So the next is the standard, just a brief one, standard before we move to the, we do the hands-on on the IoT platform. Standardization, there's so many standards out there. Actually, sometimes you get confused. which standard to use, and so on. One say ISO, one say ITUT, one say this, that, so many standards like this. Right? So here you notice this is vertical standards, this is horizontal standards. Vertical standard is specific to use case. For building, there are some standards. For manufacturing, there are some standards. So is it necessary for us to follow these standards? Sometimes yes, depends on use cases, because highly regulated. For example, healthcare sector, right? So it's highly regulated. You must follow the standards. In some cases, for example, agriculture and so on, it's not necessary for us to use, but good to use if you want to provide, or if you how to say, provide the services to international level, right? Good to have the standards. So, for example, IPSO is the IP standard. What's that? IP. What object? Smart Object, sorry. IP Smart Object Alliance. Now, this is one of the first association or alliance that was created for IoT. Now, here you will find Google, Cisco, all the big players are there. So here they define some of the common standards in terms of the protocol stacks and so on. So they define all those things here. But usually, what we align is that we align to IEC, IEEE. Of course, 3GPP is a must lah. Kalau 5G is a must, we must use 3GPP. And of course, ITUT. Okay, ITUT, where is ITUT? Here, ITUT. So these are the common standards. And of course, when you talk about this standard, the standards have different layers. 3GPP talks about mainly on the physical layer. IETF talks about protocols and communications. So similarly, different organizations provide different kinds of standards.
Kenapa panggil vertical and horizontal standards? Domain.
Pardon? Again, I didn't hear.
Vertical and horizontal domain, why they differentiate like this?
Yeah, because some are general, can be applied for all. Some are very specific to that particular domain. For example, how to control a light. It is meant for the home building. You cannot use that, or it's not applicable for other verticals. Similarly, for healthcare, there's a certain set of standards that you must comply for, either for the devices or the management system and so on. It is defined for that particular purpose. Similarly, energy, there are some standards that need to be followed. It is meant to be like that. That's why you see there's so many standards out there. Sometimes when you are in the standard body or member of standard, you get confused. You cannot actually be in all the parts actually. It's difficult. Right?
So the horizontal doesn't mean the only that it means the daily communication only, the horizontal standard. Yeah.
Not only communication, everything actually.
Oh,
everything.
Horizontal domain. Okay.
One example is II Consortium. II Consortium is Industrial Internet of Things Consortium. They have a very good documents on industry, specifically on the communication, connectivity, and so on. So you can find so they focus only industries. So if you want to look into specific documents related to industries, you can take a look at this particular site. Just the last part of this introduction to IoT, more towards the market size. So let's see, how big is the market? Is it really required for us to understand or more about IoT? Different organizations gives different figures. Transformer Insight. So this is from Transformer Insight. The market value by 2030, what they said is about 1.5 trillion. Now, this 1.5 trillion consists of all the different components, from device, the platform subscription, to data analytics, everything. And of course, here you can see what are the specific sectors: consumer, then they have vertical, specific related to water, health, and so on. And then there's a cross vertical. Right. Next is the technology market attractiveness. I want to bring your attention to this, the middle one, which is the technology view. What would IoT users are willing to pay for? One is the cloud migration and modernization of services. Most of the companies, in fact, for SMEs, they have not actually changed or moved into digitalization. So in order for them to move, they need to, well, in order for them to adopt IoT, they first need to move to digitalization. So this is called migration. Low code or no code development interface. This is the most, asked or wanted, right, by these organizations. They don't want to code. Okay, simply drag and drop and use it. In fact, that is the next wave. Low code or no code at all. There will be code, but for them to configure, they just need to just change a bit here and there, and then they can make use of it. So that's what it means. State-of-the-art cybersecurity setup, end-to-end solutions that are easy to configure, like a plug and play. Solutions supporting open APIs and data ecosystem, intelligence connected edge, offering the support their sustainability native and AI-infused software application. Now, AI-infused software application is more towards end devices that can self-learn and self-configure. Right? And next, about the skills and the job. Of course, in IoT, there are many segments. You can be good in terms of the hardware, you can be good in terms of programming, but these are some of the skills that is required. Embedded system, you can focus on the networking, you can focus on the programming part, you can focus on analytics, communication protocol, edge computing, and so on. So, soft skills. Soft skill is basically more towards marketing, right? So you need to know to market the products. And these are the top 10 programming language in IoT. The top is Java, and then you have C, JavaScript, Python. In fact, Python is now gaining momentum for analytics. Right. For IoT analytics, Python is one of the programming languages that's being used. Beside, R. Well, R is not so much, but Python, yes. Right. Node.js, C#, PHP, Lua, assembler, and so on. Technology by proportion, companies likely to adopt by 2022. So here is what I meant by, why IoT and big data is important. This is a projection by World Economic Forum in 2018. Right? So if you notice here, the top 4 or 5 is all about IoT and data. The first one is big data analytics, app and web enabled markets. This is like, e-shopping, e-services, and so on. Internet of Things, machine learning, cloud computing. So it is important. See, all the others are there, yes, quantum computing, encryption, but you see the percentage wise, IoT is about 75%, data or machine learning about 73, 72, and so on. So this is, so it is crucial, it is right time, even for universities to offer such programs, such courses. I think if I'm mistaken, UTHM has own program, both undergraduate and postgraduate. It's not a subject, but a program on its own. I know that the commercial arm of they have a postgraduate. This is one subject on IoT, and Polytechnic, they have one program. It's a diploma program on IoT. It's this Polytechnic in Seberang Jaya. So I've gave a training to them last time. So yes, so it's a good move to offer these services. Again, focus on the various aspects. As I mentioned earlier, it could be on the hardware, it could be in the programming, it could be in the analytics. There are various parts of it that can be incorporated. Right. I'm towards the end of the introductions of IoT. I know it's quite lengthy, quite long. Any questions so far? Okay, now if there's no questions,
no further question. Just
okay.
try to understand the terminology lah, basically.
Okay. Yeah, I think terminology, yeah, there are so many terminologies, yes, true. Tapi slowly you definitely can know lah. Yes, somebody asked a question, is it? Anyone else?
Yeah, Dr. Gopi, I have just one question actually. Just to get your opinion, I think. When you talk about earlier about Society 5.0, inside the Society 5.0 and IR 4.0, we have a big data, right? Big data analytics. So I just, essentially, I just want to know about your opinion. Do you think that big data analytics is actually the bigger picture, or the IoT is a bigger picture, meaning that the big data analytics is in the IoT field or IoT is in the big data field?
I feel it goes hands together. See, if you talk big data, where does the data come from? Now, if you talk about data from other sources than IoT, for example, social media, or existing data, financial data, yes, big data is important. Is IoT important? Yes, IoT is important. Why? Because without the IoT device, you cannot get any data. You cannot process any data. So it's actually together. You cannot have big data without IoT. Similarly, you cannot have IoT solutions without big data analytics. You can, but it's a simpler version of IoT, just monitoring of the solutions that you provide. For example, you're monitoring the humidity, you're monitoring the smoke, monitoring only. But for big data, is more towards analytics of the data. So which is which subset? I think it's two separate components. IoT and big data are two separate things. So they actually merge into, they intercept. Because big data is not only meant for IoT, it's also meant for other types of data. The same goes for IoT. It doesn't really require big data for monitoring, but for analytics, yes, it requires big data. That's the way I see it.
Okay, yeah. I can see that. Thank you so much.
Okay, if there is no other question, let's move to the next part. We'll go to the platform straight. Let me just introduce favorite platform, because in order for you to program the Hibiscus Sense, you need to make sure that you prepare the platform. So I'm referring to 4.0 favorite IoT platform. Like any platform, Favoriot platform can connect any devices. It could be a development kit. It could be a fully functional IoT device that you deploy for measuring certain parameters like environment monitoring, agriculture, and so on. The only thing that is required by the device is to be configured with this communication protocol, which are REST, QoEP, and MQTT, which we will learn all these three, okay, how to set up. So once you set up these devices, you send the data to the platform, and within the platform, there are various components, same like what I've mentioned earlier. It's just that we also have some microservices. We have payment, we have SMS, triggering, we have end-to-end security, and so on. So these are all the general architecture, I would say, of the platform. So why Favoriot platform? Right, so why? So what's the value proposition? Because we have so many tools, like, we are trying to move in the direction of low code or less code. Right? We are moving in the direction. So for that, we have provided various tools to improve or shorten the development time. Assuming that you want to build an IoT solution, end-to-end IoT solution, your focus would be then at the device and connectivity and maybe an application level. You do not have to worry about the platform because you can directly connect to the Favoriot platform using the tools that's already there, the APIs which is already there, which is number 2, user-friendly API. Scalable platform. So because it sits in the cloud, it can be easily scaled up, and it can also be an enterprise versions on premise. So you can get an enterprise version and install it. But of course, it's a subscription model as a license base. It's not free, right? So onboardings, I've mentioned, REST, MQTT. Notification engines. So we have incorporated email, SMS, and Telegram. We will look into all these three later. IoT resources. There are tons of documentations, video, short video tutorials. See, I know that sometimes it's very lengthy tutorials. We have divided based on the topics that you want to look for. Assuming after this training, you forget something, you want to build something, how to create projects, how to create devices. You can just go inside our YouTube channel. There are short tutorials. Okay, 1 minute, 2 minutes. So very fast. You can just follow through that. So these are some of the key features within the platform. Suppose multiple communication. We actually use hierarchy, which I will show in the next slide. What is this hierarchy? Real-time data display. So you can display the data as the data comes or gets stored in the platform. You can download the data in CSV and JSON format. We use API key to manage the data transaction. And this API key is unique for each user. Okay, it's kind of a security mechanism. You can send alerts using email, SMS, Telegram. You can display the device on the map, provided that you give the latitude and longitude of a particular device. That means we will go through that later as well. When you set the device latitude and longitude, and when there's data that comes into that particular device, you can see that on the map, the location of it, as well as the data. We have dashboard. You can create real-time graphs. You can create historical data, and you can either share it to public, or you can also for private viewing as well. You can send control from the dashboard. We will do this tomorrow. You can customize logos and graphs. You can monitor the status of the connected devices. So assuming that devices stop sending data, the platform will see, okay, this is the frequency of this particular device. If the platform do not receive any data for some time, it will change the status of the particular device. So you will see that also. Create customers and provide access. This is for developer account. So you can't see this in the beginner account, but there's a feature in the platform where, say, assuming that you create service to a third party, you can create account for that, your customer. The purpose is that, but with limited access, meaning they can see the data, they can download the data, they can see the graphs and so on. It's only meant for them, but they cannot change anything. Okay, so that's limited access. You have an option to send the data to third-party server. Whenever there's a data comes to the platform, you can configure that such that it automatically forwards to outside third-party server. Unlimited parameters. So this is one of the important features. Unlimited number of parameters in one stream. See, the device, right? Sometimes it's only one sensor, one device. The temperature, only temperature. Sometimes humidity is only humidity. And then you send the data as humidity, what's the value? That's it. In some sensors, in some device, it has multiple sensors. It has temperature, it has humidity, it has the proximity, it has light, many sensors. You can send all those in one single stream. So Favoriot platform does not limit the number of parameters. Some platforms, however, some platform out there, they limit the number of parameters. Okay, and if you want to add more parameters, you have to subscribe the higher package. But for us, no, we don't limit here, but we limit in the number of APIs. I'll again explain that number of APIs. And of course, you can enable or disable the device at platform. Now, this is what I mean by hierarchy. Favoriot platform uses hierarchy. It is from the top to bottom. It must follow this hierarchy. Meaning, first you need to create a project, then an application that tied to the project, the group that tied to the application, devices that belongs to the particular group. That's hierarchy. Why we did in such manner is for management of the data. So assuming at the project levels, I want to know how many devices that I've deployed. So you can actually extract at the project level. Or I want to know how many groups are there for a particular application. So this is the hierarchy level. So it's important, again, it is important for us to create from the top until the devices. Of course, streams are, when it sends the data, it's considered a stream. So you don't have to create the streams at the platform. Stream is when you submit or when you send from the device. Again, so what is the device here? So remember, you have Hibiscus Sense, right? Your Hibiscus Sense has to configure and send to the device that you set in the platform. Say, for example, device 1. Device 2 can be another device that you have. Device 3, another device. So those devices must be associated to the real device. This device here must be associated to the real device that's going to send the data. Okay, we will go through step by step on how to do this. Now, this is an example of hierarchy. It could be your own interpretation of how you want to set the applications and groups. This is just an example. Say under the project, you have a smart city, and then there are two applications that you can create. Say, for example, smart street light and environment. Under smart street light, it could be, you can group in terms of location, location 1, location 2, park 1, and so on. Then the devices, the name of the device. Light intensity, movement, device 3, CO2, SO2. So these are all the device. Right? So for now, so we have about over 5,000 developers registered from over 115 countries. Okay, so let's move straight to the platform. So what I want you all to do now is, let's go to the platform. I will explain one by one of how you can make use of this platform. So you can open up platform.favoriot.com. So you have, of course, you have opened it up yesterday or day before yesterday to register. Now here, you will notice there are a few, how to say this, these things that you can click. There are tutorials, I mentioned earlier, video tutorials. There are document, API, GitHub, forum, and policy. So important things to note is that you may want to see the tutorial, the document, the API, and the GitHub. Okay, sign up. You have already signed up yesterday. So let's sign up. Let's log in. Okay. So I want you all to log in first. Now, this is the main page. Now, in the main page, you will notice there's something called auto create. What is auto create? Remember, I mentioned you need to create the hierarchies from top to bottom. That means you need to create the project, you need to create the application, the group, and the devices. Auto create allow you to provide only the project name and the device name, of course, and description, and it automatically creates the application, the groups. So I will show that shortly. And then you will notice here, you see project, application, groups, and devices. For now, by default, you will have 1, 1, 1, 1, unless you have created something. Okay, so first time when you log in, you should see one project by default, one application, one group, and one device. In the device detail section, if you have devices, you can go through all the different devices, and you will notice that each time you move, there's a data stream. This is a total data stream for the particular device. And then below that, you will see the parameters for that particular data stream. Here you will see API limit. Now, for beginner account, which you are using, the total API usage is 5,000 per day. What is API? When you send data, is considered one API. If you have, say, if you have 10 devices, sending data every hour, that means per day, it will be 10 times 24, 240. Am I right? Yeah. So one device will send 24 streams per day. So 10 devices will be 240 APIs. This is for sending data. Okay, so here you can see 0. That means I have not used the API. I have not, plug in my sensor. So no. And it gets reset at GMT 0, meaning at 8 AM Malaysian time. So every day at 8 AM Malaysian time, you will see your API goes to 0. Okay, so far clear? SMS is that a subscription. You need to buy the SMS package, is 5 ringgit or 10 ringgit. 5 ringgit for 50 SMS, 10 ringgit for 100 SMS. And only then you can use the SMS for rule triggering, okay, to send out the alerts. So where do you see your account details? Here, beginner account. You can click the beginner account or setting, either one. So if you click that, you will notice that you can choose. Sorry, this is all your personal information. User ID is unique. Your email is unique. The rest you can change. In fact, you can change this also, but must be unique. You can change user image if you want to. That means the logo, your favorite here, it will change to your image. Say, if I choose, where's my picture? Say I put here. This one. Okay, so I've changed this. Okay, of course, you need to save the changes. I'll show that later. And then here, the bottom here, you will see the subscription, your beginner account, expiry date. Now, this API key. API key is an important key to be used in programming later. We will use this API. Now, there are two API keys. One is the read-write API key, and it's unique to your account. The other one is a read-only API key. In the read-write API key, you use this in each device to send the data, to update the data in the platform. This is meant by read-write API key. Read-only API key is you can use this, for example, to retrieve data from the platform. Say, for example, you have hired a third-party application developer. You don't want them to, manage the data, but you give access to them to retrieve the data. So what you do, you give read-only API key to them. It's a very long API key. Okay. A password, you can change the password. Let me save first.
Okay.
Next.
Both API keys also 5,000 times.
Pardon? Both API key?
Also 5,000 times per day.
Yeah. API key is 5,000. Doesn't matter. 5,000 per day.
Read
both.
only. Read
Both.
only
Both.
5,000.
Both.
Both.
You will see subscription plan. Okay, this is normal. Add-on is if you want to purchase SMS or SMSs for now. So I mentioned earlier, and you see the transactions here. Again, API key is important, and we will use this API key repeatedly in the code later on. Okay, this API key. Okay, let me go back here. So in here, let me plug my sensor first. So here you will see in the hierarchy, how do you create the hierarchy? You can do one by one. We will do the exercise after the break, after lunch break, but let me explain now. You can either create project, application, group, and device one by one, or you auto create. Say auto create, I say device name, I put the okay, so just notice here project name and device name. So I add. So what happens is that if you go to project, this is created. Okay, the project is created. And you did not create the application, but automatically added on. And these are all unique. So if you notice, this project developer ID, sorry, these are unique. The developer ID is unique. And then if notice here, UNIMAP app, what is, it belongs to project called UNIMAP. Group, it belongs to, this group belongs to UNIMAP _ app at Gopinath. Devices, because we have given the device, here you go. Okay, so this is one way of creating automatically. What we will do later is create one by one. First, we create projects. Create project. Say I put the active or not active. Active means you can receive data, non-active means you cannot receive data. So see clearly, once you automatically create, right? So you notice that it gets updated. And here they have three buttons here. One is to view, second one is to edit, the third one is to delete. So view. If you click view, if you notice, there's no application associated to it because I've not created application yet. Next, we create application. Simply click the create application and say, okay, active. So which project this Smart Campus belongs to? So put the training UNIMAP. So I select that and put a description. Again, you will see this. Same goes for group. Create a group, say location, building 1. Which application? Smart Campus. Okay, this one. Let's get updated here. And the last one is the device. Okay, I'll say building 1 temperature. Now for device, there are a lot more that you need to do. This active, okay, leave it active. Group developer ID, put building 1. Description, measure temperature, medium. Type. Now you can, it's not, okay, it is compulsory field, but there's no specific need for now. So you can just simply say device type could be, say, Arduino. Later on, when you type in, you can provide any name. Sensor type, temperature sensor. Time zone, Kuala Lumpur, Singapore. Here, the map. If you, it is not a compulsory field, it's not mandatory field. But if you want, you can give the latitude and longitude. If you know the latitude and longitude, you can just simply put it in here. Or if you don't know, you can zoom in. You can move this marker. Say, I put it here, Puchong. Okay, this is our office somewhere around here. Is this our office? Oops, that's somewhere here. Okay, so once you move, the latitude and longitude will change accordingly, and then you just simply create. So you notice, oh, I put it as, so I put it active as not active. So I've changed it. So how do I change? Go to edit, device active, change it to yes, and update. So now you'll see it is active. The purpose of active, not active is that like you are turning on and off. I mean, not really by the platform level. Even if the device sends the data, you don't record it in the platform and the API is not counted. Now, what are the other things? So if you go to edit for device, you will notice there's something called configure access token. Okay, in fact, if you go to view also, there's an access token. Okay, let's see the view. No, let me go back. Click the view. If you notice the access token now, this is similar to the API key, the long API key. The long API key can be applied for all the devices, for everything. Every communication transaction that's happening with the platform, use that long API key. This access token is specific to this device only. You can also use this access token to send data, but only for this device. It belongs to this device only. We will use this access token later. Okay, we'll explain that later. On top of that, you will notice in the edit section, there's something called operation. By default is 5 seconds. So assuming that you want, you set your device to send data every hour. So you can also put it as an every hour if you want to. Okay, the platform will take note of this and update accordingly and checks whether the device sends the data every hour or not. Okay, for now, we will leave it as 5 minutes. So this is what you need to do in order to receive data from the device itself. Okay, so once you set this here, then we can go and configure the device to send the plan. So where do you see? We will do that later. Here, if you notice view on map, so you will notice all the devices that's on the map, which only the connected devices for now. Okay, so device 1 is connected. Created on when it was created. Okay, it's disconnected for now. Okay, so this is disconnected. Device 1, or maybe I don't have the latitude. I've not set the latitude and longitude. So you will notice here, I only set one device which is disconnected. Okay, so the bottom, you will notice the same thing in summary, all this information. Now, sometimes we forget which device belongs to which group or belongs to which application, right? So one way to see that is using this hierarchy overview. In the hierarchy overview, for example, I have 7 projects. Say if I click training, I have 1 application, 1 group, 1 device, and the status of it. Similarly, say training, this is 1 group, there's no devices here. Which one got DOA app? Let's say I just want to see the one that active. Check. So it's not smart city. Yeah. So you see here, so this is active for now. So this is what one of the devices active. So you can see in detail if you forget which device belongs to which group, which applications, and so on, by simply clicking this hierarchy overview and see all the details. Now, can you change the groups and applications once you commit? No, you can't. You cannot change the hierarchy once you create. You can only delete and do it again. Delete, you can delete at each level and then create again. But once you commit the hierarchy, you cannot change to a different. Meaning to say currently device 1 belongs to group 1, and you want to change to group 2. You cannot do that. All right. Any questions so far? If no questions, is there any questions? Yes. If no, we will take a lunch break now. It's 12:50.
Hello, Dr. Gopi.
Yes.
Is it possible to show from the beginning, from the create device, because I'm just lost? Maybe
Okay,
after lunch.
Okay, can.
Yeah, because I'm using single display, so it's maybe I need another laptop to to more focus on the screen and also. Yeah,
it's very straightforward anyway. Let me just explain before the lunch, because after lunch you all need to do the device and everything. It's very straightforward. For creating the projects, applications, and groups, you click the hierarchy, click the project, create the project. You just provide any name of the project, the description, and then you create. It will create the project for you. So it will appear here. Next step, go to application, create application. So say example, you training something active, and then you need to select which project it belongs to. the one that you have created earlier. Provide description, and then you create. Then you go to groups, the same process. Create a group, choose which application this group belongs to. Then you create. The last one is device. So for device is a bit more. You need to provide device name, device group developer ID, device type. Now, you will notice here there's device type and sensor type. You can provide any device type for now. You can put Arduino, you can put Intel device, you can put anything. Sensor type, you can put temperature, it doesn't matter. Okay, later in the exercise, doesn't matter. You just can put anything here. Time zone, you put select Malaysian time zone. And then for this, you move the cursor, the marker, or if you know the latitude and longitude, you can just put it here and then create. So once you have done all those things, you will notice the devices are here, the groups are here, the applications are here, and the projects are here. Okay, never mind. We will do step by step after the break on how to create.
Dr. Gopi.
Yeah.
If let's say we have deleted the projects, let's say we have done something wrong on the hierarchy, and then we decided to delete all. So when we create the new one, we have to update the token to the programming language, right? Or we can use. Okay. Now in the API, as I say, it is best to use the API key. This API key. This API key remains the same. It doesn't change. Okay. But if you use device specific token, yes, you need to change. Because device specific token is unique to the particular device. If you delete the device, it will disappear. You need to reprogram the device with a new access token. That's why it is important for us to, design, identify everything before we put in the code. Does that answer your question? Yes. Okay. Thank you. All right. Okay.
Dr. Gopi, Arif here.
Yes.
You mentioned just now once we commit, then we cannot undo, except we delete it and do it again. Which stage is commit?
Commit means is once you create it, it's considered commit.
Oh, but we still can edit it, right?
Yeah. You can edit the device, but you cannot edit the group it belongs to. Say, for example, I'll show you this. See here, configuration. See, in the device section here, there's nothing mentioned about which group it belongs to. Now, the reason why is that the platform, the data in the platform is stored in such a way that it belongs to this particular hierarchy.
Yep.
Suddenly, when you change it, the structure will change. So we do not want to allow that to happen.
Okay, I understand. Thank you.
Right? Okay. If no questions, so what we will do, we'll stop here for a lunch break. After we come back from lunch break, we will do hands-on, create the hierarchy, play around with the devices, and then we will go to hands-on in the setting up the Arduino IDE, get familiarized with the Hibiscus Sense. Okay?
All right.
Okay, so have a nice lunch. See you all at 2 o'clock.
Okay.
See you all at 2 o'clock.
Can we leave and log out and log in again later, right?
Can.
Okay. Thank you all.
All right.